Hello, my dear students. Welcome to this lecture. So in this lecture, I'll be taking one commercial building, and for the same building, we'll try to see how the plan is prepared, and we'll try to see the structural drawings that is required for our understanding, right? So I'll be taking you to one of the plan now. Yeah. So right now, this is one of a commercial complex, which we are presently doing. And just have a look at the plan, and then I'll explain you all those things, right? So when I say commercial building, it means maybe you're using it for some rental purpose. You are renting it out to someone, right? So in that case, we either require a shop or something like that. Now if you look at here, you can see what is written. We have written a shop here, and they have written one more shop here. Of course, this is a road, and then we have written one more shop here, and this is a staircase for us, right? So this is a typical plan what we have prepared. So whenever we prepare the plan, what we do, we need to give the dimensions of the room. I'll write it here quickly. Dimensions of rooms. Okay. And the second thing is that about the column location. Column location. These are the two important things that we are supposed to keep in our mind when we do the plan. So the same thing you can see it is reflected here. Of course, you can see the dimensions being given here: 17 feet 6 inch into 10 feet, 29 feet into 6 inch into 19 feet by 6 inch. And of course, you can see here 14 feet 6 inch into 29 feet into 6 inch, right? Yeah, 29 feet 6 inches. So always we know that the first is horizontal distance, that is this is 14 feet 6 inch, and this comes out to be 29 feet 6 inches. Yeah. Now you check out the columns here. We can see a column here, right? We can see one more column here, a column here, a column here, and the green ones are also the column. Now here you can see a purple color column, whereas these are my green color columns. So this is for the better understanding. So usually when we draw any plan and all, we'll be having a different column sizes, right? Let us say it's a 9 inch by 15 inch, or let us say a 9 inch by 12 inch, or let us say a 9 inch by 18 inch. So here this pink color represent one size of column. I'll now even I don't know what is the size of a column, but still let us consider the pink column. I mean the pink color column are the 9 inch by let us say it's a 12 inch column. What? And then the green color columns are, let us say, usually 9 inch is a common size what we adopt, and let us say it is a 15-inch column. Got it? Yeah. So this is a basic understanding we need to have. One more thing, always remember, whenever you put the interior column, those columns will be of greater size compared to your external columns. What I'm trying to tell is, so this is my external column, which is outside. This is also outside. This is also outside. Of course, here all the columns are at the outer side only. But let us say I had one column somewhere here. Let us say I had one column somewhere here, and I had one column somewhere here. So in that case, what has happened? This column is inside, right? Because if this is my outside column, these columns are inside. Usually the columns which are inside, we try to give greater size to that, because the load coming on the interior column is more when compared to the exterior column. So that is a concept we adopt, and we can try to see in an entire series of our lectures. All those things are reflected in the structural drawings. Yeah. So I hope up to here your concepts are clear. We have understood. Quickly, I'll go through this drawing once again. Okay. So this is a distance between given in between these two column. It is 10 feet, and we have a road passing here, and we have a 4 feet 6 inch wide passage here. So we have a 4 feet 6 inch wide passage here from here to here, and this is a 3 feet from this outer of this column to this outer. We have a 3 feet distance. That is the offset what we have. Got it? So in this way, this is my ground floor plan. Now you can see something is written here. Ground floor built up area is 1547 square feet. So this is a total square feet. How much square feet is your total building? That is a built up area. They mentioned it here. In the next lecture, I'll try to teach you how to calculate this area, but right now we'll try to concentrate only on the plan. Got it? Now I'll be taking it to one more plan. This is a ground floor plan, since it's a G+1 building. Now right now I'm in the first floor. You can see it here. First floor built up area, which is 1757 square feet. Yeah. So now again you check out here. So it's the same thing. Whatever you had it here, right? The same thing we have taken to the first floor. Always remember, whatever columns you are given, wherever you place the column, the same column will go to the next floor. We cannot deviate the column. Let us say in the ground floor I had a column here. When I come to the first floor, the column will remain same. Got it? You cannot take your column somewhere here in the first floor. So that is the basic fundamentals we need to understand. And you can see all those things are reflected here. Yeah. Yeah. So now just see here. Again, you can see here. Yeah, we have the same staircase coming here. We have a column here at the outer portion. We have all the column. Again, we have made a hall here. We have one more hall here. And then there is a shop given to here. So the people coming to the first floor have to take the staircase from here. And it's a small hall they have made, because since let us say if you're doing any functions and all, you require a small hall. So it's almost a 1000 square feet hall. Let us say at least a 50 to 80, 90, 80 people can accommodate in this particular hall. And here they have given it for a shop. So that is how the entire planning is done. And that is how you're supposed to understand this drawing, right? Again, you can see the columns here. Now you are very clear. The green color column represents one size of a column and the pink is the other size of a column. But only what changes has happened, almost everything is same. We have a column here, here, 4 columns. The same 4 columns have come here. There's no changes in that. These 2 columns what we had, the same 2 columns are here itself. Okay. And I don't think there is any changes which has happened in the first floor. See, sometimes what happens, you may not have a column in the ground floor, but when you come to the first floor, you may have a column. What I'm trying to tell is, let us say I don't have a column in the middle portion. Okay. But when I come to the first floor, there is a chances I may have a column in the middle portion somewhere here. So such columns are called as floating columns. I'll write it here, floating columns. We'll try to see the floating columns and all in the upcoming lectures whenever we take such drawings. Since it's an advanced course, we'll be trying to take such things which are not covered in my earlier course. So some people call this as floating column. Some people call this as a stub column. Okay. Yeah. So these are 2 names given to that column. So here, this column will not have any foundation. It will be just resting on the beams which is given here. You have to give a beam here, and over the beam, this column will be coming. So hence it is called as floating column. Since it is floating, okay, since it doesn't have a foundation, since it is floating, we call it as a floating column. And some people call this as a stub column. Yeah. So this was all about the plan, what I have taken. I hope up to here your concepts are clear. And we have a toilet here, and even in the ground floor. Yeah. So this portion was made as a toilet in the ground floor. It was not mentioned here, but this is a toilet what we're trying to use. And here also we have a toilet in that. And this particular symbol represents that it is a door what we have. And from here to here, we have a 4 feet landing distance. Okay. So that we can go to the toilet from here. Yeah. So other than that, rest all things are very clear to us. So in the next lecture, I'll teach you how to, again, you can see it's a 1757 square feet what we have. In the next lecture, we'll try to take out the area of this. Yeah. So I hope you have enjoyed the lecture up to here. We have understood what exactly the plan looks for this particular building. And in the due course of the time, we'll be able to understand all these things. I'll show you the drawing now again. See, I want to tell one thing here. Whenever we do the architectural plan and all, right, sometimes there will be a revision in that. Maybe the client initially he'll say, okay, this is a plan what I want, but maybe after some days he may feel, okay, this staircase I don't want here, I want to move this staircase somewhere here. Something like that is going to happen. So initially when we proposed the plan, this was our plan actually. Okay. And later the client told that this particular space what we have, no, what we are going to do, we'll bring the staircase here. That means we'll start the staircase from here, and this much portion what is left on, we'll utilize it for the toilet room. So that is why you can see it here. You can see the staircase has moved here, isn't it? See here, this is the original plan where the staircase was here, but now we shifted it here. You can see the staircase is here, and this much part what you saw, no, so we have utilized this as a toilet. So again, for that I can show you here, you can see it here, no, this was utilized as a toilet. Got it? So right now I'll teach you the built up area calculation for the original plan. This was the original plan what we had, and for this we'll try to do that, and we'll see how to understand it. Okay. Now whenever you try to calculate the built up area, try to just see it like I want to find the area from here to here. This is 1. Okay, because this is a shop here. Then I'm going to calculate from here to here. This is my second built up area. Then I'll calculate for this particular portion. I'll take a different color for this particular portion, 3. And finally, I have another portion left out here. I'll take this much part. So if I add all this 1, 2, 3, 4, I should get an answer of 1547 square feet, right? Now I'll explain how it has to be done. See, we know from here to here it is 19 feet, and from here to here it is how much? 10 feet. You can see it is 10 feet from here to here, and from here to here it is 9 feet. Just multiply that. We'll quickly do that. So 19 into 10 into 10, how much it is? It is 190 square feet. That square feet word should be, word is very important. Now again, try to see here, how much is this? Again, we don't know how much is this exactly, right? But we know from here to here it is 31, from here to here it is 31, and I want from here to here. So what I can do, 31 minus, we know this is 10, so 31 minus 10, if I do, I'll get this. This is 21, and from here to here it is 31. So I'll do in this way. This is 31 horizontal, and vertical is 21. Try to do it manually, and we should get the answer as 31 into 21. 31 into 21, it is 651. So this is square feet. Yeah, so this is 651 square feet. Now try to do for this. We know this is from here to here, how much it is. So from here to here the length is not mentioned, but I know from here to here it is 21, and from here to here it is 10. So 21 plus 10 comes out to be 31, and this is how much? So even this also I don't know, but I know from here to here it is 36. I want from here to here, so I mean, sorry, from here to here it is 26, but I want from here to here. So 26 minus 10, if I do, I'll get 16. Getting my point? So quickly, if you want, I'll show it here. Yeah. See, from here to here it is mentioned 26, and we know from here to here it is 10. It is mentioned here 10. Okay. So can I not find from here to here? Of course, 26 minus 10 will give me this answer, which is 16. So quickly I'll do that. 26 minus 10, 10 is 16. Into this height is 21 plus 10 is 31. So try to do this. So again, 16 into 31, it is 496 square feet. And finally, I want to find this much area. Again, I know from here to here it is 10, and from here to here it is 21. So of course it is 10 into 21, which comes out to be 210 square feet. And I'll keep it here. Got it? So this is how you're supposed to do. Now very simple calculation I'm supposed to do. This is 190 plus 651 plus 210 plus 496. Try to add all these things. You should get answer of 1547. I'm doing it manually. 190 plus 651 plus 210 and plus 496. So I'm getting 1547 manually, and you can see it is 1547 square feet here. So this is how you're supposed to find the built up area. Okay, now we'll do it for the other floor also. So this was another floor what we had. I'll go here, right? This was another, that is the first floor. Here I should get 1757, and try to do it manually on yourself. I'll quickly guide you how it has to be done. See, we know this is 19. So 19 into 10 will come out to be how much? 190. I'll do it manually. 190 plus, again, I want to find from here to here. So it is how much? So already from here to here, it is how much? This is 31 plus 10 comes out to be 41, and 41 into, I want from here to here, from here to here. Okay, that means from here to here, here. So how do you find that? Again, it's very simple. From here to here, here to here it is mentioned 31. 31 minus 10 is 21. So this height from here to here it is 21, and this we know it is 41. So try to do that. It is 21, and this is 41 for me. So I'll multiply this into 41, and then this again, it's the same thing. From here to here it is 16, right? Because I want from here to here. This is 26. 26 minus 10 we are supposed to do. So this is 16, and 16 into this is 31. So again, plus 16 into 31 plus, and lastly I have to add this thing. So this was actually 10, and this is 21. So it was 210 plus 210. I'm doing it. So I'm getting 1757. So you can see it is 1757. So if you're not able to follow, quickly I'll do it here. Okay, so it is 19 into 10 here. So it is 190 here. Square feet, I'm not writing square feet. You do it on your own. Again, this is how much? 31 plus 10 is 41. So 41 into this is 21. So if I do this, 41 into 21 is 861. Okay, and this is how much? This is 16 into so this should be 31. 16 into 31. So this is 496, and this is 210. 210. Okay, that is 10 into 21. So try to add all these things. If I do that, 190 plus 861 plus 210 plus 496, I'm getting 1757, and you can see the built up area what they have got is 1757. So in this way, whatever drawing you get in future, if somebody asks you how do you find the built up area, so this is how you're supposed to find the built up area. Got it? Yeah. So I hope you have enjoyed up to here. You understood how to calculate the built up area. So I'm not going to go in too much depth, or let us say very fundamentals, like what is the center line and all. If you had taken my site engineering course, or if you had taken my earlier drawing reading course, you know by this time, and we'll go with that logic, hoping that you know all these things. But still, we know that A, B, C, D, all these are my grid lines in the vertical direction, and 1, 2, 3, 4 are my horizontal grid lines. This much is clear. Now, see it here. Whatever column you're placed, like you can see a pink color column here, 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 and here. So these are 4 individual pink color column what I have, and under that I need to provide the foundation, and you can see it here. This is a 1 foundation, 2nd foundation, 3rd, and 4th. Similarly, you can see the green color column here, and these 4 are placed in one line, and this is another one here. So these 2 are in straight line, and these 4 are in one line, and under all these 6 columns, 1, 2, 3, 4, 5, 6, we have a foundation. So you can see 1, 2, 3, 4, we have 4 foundation here. Another 2 column, we have another 2 foundation. Similarly, all these 6 columns are in straight line, and again under all the 6 columns you are going to provide the foundation. So you can see all the foundation being provided here. So it's written here, these are the center line details, and this drawing is very important to do the plotting on the side, how to place, the center to center distance. Now coming to the dimensions of the footing, how do you understand? So this is your C1F1, 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 and C1F1. They are given a name to this, whichever is my pink color column, isn't it? For this, we have given a name of a footing as F1. And on that F1 footing, we have a C1 column. So you can see C1F1 means the name of a footing is F1. And over that, we have a C1 column. Similarly, we have all these things. Again, we have a F2 footing, the green color, the name of the column is C2. And beneath that, we have a F2 footing. Got it? This much is clear up to here. Now, usual practice is that whatever footing we have, we give the dimensions for this footing in all the sides. That means we mention for this footing what is the length and what is the breadth and what is the column size. For each and every footing, we do the same thing. But here, what the engineer has done is that he has taken one master column or one master footing. Let us say this is C1F1, and he has given all the dimensions here. So that means even for this also we have to refer the same dimensions. Even for this C1F1, C1F1, for all this C1F1 column footing, we have to refer this particular dimension. Similarly, for C2F2, he has given one master dimension here. Again, you can see all the dimensions given here. The same dimensions you are going to copy, or you are going to do the execution for all this 1, 2, 3, 4, 5 footing C2F2 with the same dimension, right? So that is why they have given. Sometimes what people do, for each and every footing, they are going to give the dimension. That is also okay. Here, instead of doing in that way, they have given, since there are only 2 footings, they are given in this way, and this is also okay. Now we'll try to understand this. So again, of course, this is very basic. We know that this is a column, and the size of the column is 9 inches, the breadth of your column, and the depth of your column is 1 feet 3 inch. When I say depth, see, when I say depth, it's not height. For the column, if it is height, if this is my column, then this will be my height. Okay, this will be my height. This will be my height. This will be my breadth, and the other side it will be a depth. If I draw it in 3D. Okay. So right now we are seeing only the plan. So when I see the plan, I can see the breadth, that is 9 inch, and the depth, that is 1 feet 3 inch. Okay. Or I can say breadth and length of the column. Okay. Yeah. Now again, you can see a 2 feet 9 inch and 3 feet 3 inch is mentioned. 5 feet 3 inch and 5 feet 9 inch is mentioned. 5 feet 9 inch and 6 feet 3 inch is mentioned. What exactly is this? For this, we need to understand one more thing, that is a foundation details. So right now we are looking at the step footing. Whatever footings we are seeing, right, it's a step footing. Step footing in the sense, you see it practically here. Yeah. Yeah. So this is how a step footing looks. Okay. So that means we'll be having a lot of steps here. So this is my first step. Okay. In this way, where this is a breadth and this is a length of my footing. Then this is my second step. Again, this is a length and this is a breadth of it. I'll tell the other way around. So let us say this is my first step. This is length and this is breadth of it. Let us say this is again length of my second and this is a breadth. And if there is one more step, it's a 3-step footing. Based on the requirement, we try to do that, right? This much is understood. And this will be the depth of my footing. That is the second step. And this is the depth of my first step, right? So I hope this much things are clear for us. So with this understanding, we'll go back to the drawing again. So the same thing you can reflect here. See? Yeah. So this is your first step. This much area, what you can see. This is your first step. Okay. And then this is my second step. This is my, here we have taken only 2 steps. Got it? And what is the depth of the first step? The depth of your first step is 9 inches and the depth of your second step, it is 9 inches. Altogether, it is a 21 inch. And this 4 inches of PCC, sometimes we call PCC as a bed concrete. Again, the size is mentioned here. Got it? Now, this is one way of understanding. If you want to understand it here, you can understand even from here. Now you know the logic behind this. So what exactly is this? So this is my first step. So if I do it here, you can see this one. This is my first step. Okay. And this is my second step. This is my second step. And of course, the pink color is my column. Okay. So what is this dimension of your first step? The length of your first step is 5 feet 9 inch and the breadth is, it is 5 feet 3 inches. Got it? Now coming to the yellow color, it is the second step. Again, the length is 3 feet 3 inch and the breadth is 2 feet 9 inch. Now what exactly is this 5 feet 9 inch and what is this 6 feet 3 inches? So actually, what is that exactly? So if you remember, whenever we do the execution on the site, first we do the excavation, right? And then we put the PCC. Then we put the PCC. And we know for the PCC, we take offset of 100 mm on both the side, isn't it? 100 mm comes out to be 4 inches, or sometime some people take this as 3 inches also. Anything is okay. Now here what they have done. So now you know how this 5 feet 9 inch has come. So this is my 5 feet 3 inches. But this dotted line you can see, right? This is a PCC, right? Which is a 4 inch. In the plan, if I show you, I mean, in the cross section, you can see this is a PCC what they have put and it's a 4 inch thickness. So here that PCC, what length, how much offset you have to put, they have mentioned it here. So if this is 5 feet 3 inch, from here, if I add another 3 inch, from here, if I add another 3 inch, 5 feet 3 inches from here to here. I'll write it in this way. Let me write this as 3 inches. This one. And similarly, I'll write 3 inches here also. Got it? Yeah. Now try to add it. You are going to get the same answer. Now, if I want to find this length from here to here, how do I find that? It's very simple. From here to here, it is 5 feet 3 inch. And if I add another 3 inch to that, it comes out to be 5 feet 6 inch. And this side, if I add another 3 inches, it comes out to be 5 feet 9 inch. So that is why you can see 5 feet 9 inches mentioned here. Similarly, try it on this side also. Again, we know from here to here, it is 5 feet 9 inch. Add 3 inch from this side. Okay, this is 3 inch again. So it comes out to be 6 feet 2 inches. Yeah, it comes out to be 6 feet. It comes out to be 6 feet because 5 feet 9 inch plus 3 inches comes out to be 5 feet 12 inch, which is 6 feet. And again, from here, if I add 6 feet, 3 inches, it comes out to be 6 feet 3 inches. So that is how you are supposed to understand this. And of course, this is the second step what we have, right? Similarly, if I take you to one more footing, try to understand this, okay, quickly. Again, very same thing. What is my, which is my first step? This is my first step from here to here, which is 5 feet 9 inch and it is 6 feet 6 inch. And which is my second step? This is my second step. And the size is 3 feet 6 inch by 2 feet 9 inch. Again, how did we get this 6 feet 3 inches? Again, we have taken a 3 inch offset from here. We have taken a 3 inch offset from here. So 5 feet 9 inch plus 3 inch comes out to be 6 feet and 6 feet plus 3 inches comes out to be 6 feet 3 inches. Similarly, from here to here, we have 6 feet 6 inch and 6 feet 6 inch plus 3 inch comes out to be 6 feet 9 inch. And from that is a 3 inch offset we have. And from here also we have a 3 inch offset. It comes out to be 6 feet 9 inch plus 3 inch comes out to be 7 feet. So that is why you can see 7 feet given here, right? So this is how we are supposed to understand. Got it? So I hope up to here your concepts are clear. Now we'll go to the cross section part. Now coming to the cross section, this was a plan for one of the footing what they had shown. I'll take this one right now. Okay, now come here, just concentrate here. Yeah, again same thing, this we have understood. I'll not repeat it again. Quickly we'll see what is given here. They mentioned the dotted line is the excavation line. Okay, the dotted line is your excavation line, what you're supposed, this much excavation you're supposed to do. And then after that, the one which is blue color, the blue color line, it's the RCC footing, which is a first step, and the dimension is how much? 6 feet 6 inch by 5 feet 9 inch. You can see it here, and into 12 inches. This 12 inches is the thickness what they have given. So to check the thickness of this, you have to come here. So this is my first step, isn't it? So it's a 12-inch here, right? I hope you are able to understand. So they have mentioned it as 12-inch thickness. Here in the plan, you never get the thickness of anything since it's a plan. Only in the cross section, that is a section you are going to check what is the depth of your footing, which is a 12-inch. Now the blue color one, this is a blue color one. It is my second step. So it is RCC footing second step. Again, the size is, it is a 3 feet 6 inch by 2 feet 9 inch. Again, we don't get a depth here. Come here. This was my second step. And what is the size? What is the depth of it? It's a 12-inch. So you can see has mentioned 12-inch thick. THK stand for thickness. That is a thick. Got it? Yeah. So in this way, you're supposed to understand. And now coming to the column, see, we have a column here, isn't it? So what is a column? It's written RCC column, and the size of the column is mentioned here. It is 9 inch by 1 feet 6 inch. So here it is mentioned 9 inch by 18 inches. Why is that they have mentioned 1 feet 6 inch here and 18 inches? This column has written in inches. 1 feet is actually 12 inches. 12 plus 6 comes out to be 18. So that is why he has mentioned 18 inches, or you can write 1 feet 6 inches. Both are one and the same. Got it? Yeah. Now similarly, come to this part. We'll come to this a bit later. 16 dia, 8 bar and all. We'll not see the reinforcement now. Reinforcement I'll take you in the next lecture. Okay. Now come to this part also. Again, this is a plan of a C1 F1, and this was a plan of a C2 F2. We have a 6 number of column of C2 F2, and we have a 10 numbers of column as C1 F1, right? If you want, you can cross verify. Quickly come here, check how many C1 F1 are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So hence it is mentioned 10 number. How many C2 F2 are there? So C2 F2 1, 2, 3, 4, 5, 6, and obviously we are matching that. We are getting 6 number. Got it? Yeah. Now come to this one. Again, now you know this dotted line is my excavation line. I have to do an excavation of this, that is 6 feet 3 inch into 5 feet 9 inch. And then again, come to the first footing. It is the RCC first footing, the blue color, which is 5 feet 9 inch into 5 feet 3 inch into 12 inch thickness. This 12 inch we are going to get from here. So this is the depth of my first footing. Now come to the second part. The second is a blue color, this one. Okay. Yeah. And this is again RCC footing second step, which is again 3 feet 3 inch into 2 feet 9 inch. The thickness you won't get here. Come here. This is my second step, isn't it? So I'm getting 9 inch here. So you can see a 9 inch thick written here. Got it? And other than that, yeah, column. Now coming to the size of a column, yeah, check out what is the size of a column. It's written 9 inch by 1 feet 3 inch. So you can see RCC column is written, which is 9 inch by 15 inch. Again, why it is 15 inch? Because 1 feet is 12 inches. 12 inches plus 3 inches comes out to be 15 inches. So they have written 15 inches here. Other than that, forget about the reinforcement. We'll come to the reinforcement a bit later. Rest all remains the same. Again, you can see the overall section here. So this is what is the thickness of your PCC? It is a 4 inch thickness. Now, I told you that we are taking a 3 inch offset, right? If you come to the plan, if I go back to the plan, yeah. If I go back to the plan, I told you that this 3 inch offset you are supposed to take, right? So from here it will be 3 inch, 3 inch. It will be 3 inches, and from here it will be 3 inches. So sometimes in the drawing they are going to mention that, like they are going to mention it here. Actually here they haven't mentioned it. If they haven't mentioned it, you can take 3 inches or 4 inches based on your site condition. Okay, so here actually they'll mention from here to here it is 3 inches, and from here to here it is 3 inches. Got it? They haven't mentioned it. In some of the drawing they mention it. Okay, yeah. So other than that, rest all things we have understood. See, this PCC, we call it as a bed concrete also. Again, they have mentioned the size of it, which is 6 feet 3 inch into 5 feet 9 inch into 4 inch is the thickness of this. And then other thing, this is the first step. This is the second step. And these are your column reinforcement. This is the RCC column what we have, right? So I hope up to here your concepts are clear. When I take the next lecture, in the next lecture, I'll teach you, or will try to understand for this C1 F1 column, what is the footing reinforcement we are supposed to provide? Because we have understood the size of footing, we have understood the depth of the footing, we don't know how much reinforcement we are supposed to provide in the footing, we don't know how much reinforcement we are supposed to put in the column. But of course, from the drawing, everything is mentioned. We'll see that. Similarly, we'll take up C2 F2 footing also, and we'll try to see for this F2 footing what is the steel we are supposed to give in the footing, and also for this particular column what is the steel and the lateral ties. Lateral ties in the sense, we know that these are the rings what we provide on the side, isn't it? So these are called as lateral ties. We'll see that how to provide this lateral ties. Got it? Yeah. So I'll take you to the same drawing once again, and the few things we'll try to see. Right now, coming to the this thing, that is a footing. In the footing, we are supposed to keep the mesh, isn't it? So what diameter of a mesh we are supposed to keep, it will be mentioned here. So just concentrate on this part, the yellow color one. So what is written? 10#10. That means you have to make use of a 10 diameter bar at 6 inches center to center spacing. Both the ways means we have a shorter span and we have a longer span, right? So if I check this particular footing, this is my shorter span and this is my longer span. The longer, I mean, this is 5 feet 9 inch and this is 5 feet 3 inch. Of course, my 5 feet 3 inch is a shorter span and 5 feet 9 inch is my longer span. So this is both the ways. You have to make use of a 10 diameter bar at 6 inches center to center spacing. So quickly, I'll tell you how it looks practically. So if I, no, yeah, I'll go in this way. So I'll put the bar in the shorter span first. Okay. So this is my first bar. I'm going to put second bar, third bar. Okay. In this way, I'm going to put all my bars. Yeah. So this is my shorter span bar. What is the diameter of a bar? I have to provide a 10 diameter bar at 6 inches. So this center to center distance, we know that, but still I'll quickly tell you 6 inches, 6 inches, 6 inches, 6 inches, and 6 inches I'm supposed to follow. Now come to the other part. So this is my longer span. Here also I'm supposed to keep the bar. So I will keep it. I'll keep my first bar here. I'll keep my first bar here. Okay. This is my longer span now. And then this is my second bar. This is my third bar. Okay. And this is my fourth bar, fifth bar, sixth bar, and so on. Got it? Again, here also I have to make use of a 10 diameter bar, and this center to center distance what I'm maintaining, right? So this center to center distance, I have to keep it as 6 inches, 6 inches, and 6 inches. Got it? So this is a practical meaning of this particular term, 10 diameter bar at 6 inches center to center spacing both ways. Yeah. Now come to the reinforcement for the column. Again, for the column we have understood. Now it's mentioned you have to provide a 16 diameter 4 bar and a 12 diameter 4 bar. So now where it is mentioned where you have to provide 16 diameter and where you have to provide 12 diameter. So for that, we just need to check here how it has been given. So there is no much differentiation given here. So when there is, I mean, differentiation in the sense, see, he's showing this is my 16 diameter bar and he's showing me this is my 12 diameter bar. Okay. So the usual practice what we follow is the outer bar we try to give a bigger diameter and the remaining one we try to keep it as a smaller. So from my understanding, so this is 12 diameter and this is also 12 diameter. Okay. So this bar, this and this four are outer bar. Okay. So this is my 16 diameter 4 bar. So 1, 2, 3, and 4. Now which is remaining? This one is remaining. This one is remaining. This one and this one, right? So this is a 12 diameter 4 bar we are supposed to provide. Now the question is that why is that the larger diameter bar will be always placed at the outer? Because there's a concept of lever arm. If I take this as my neutral axis, okay, from here, this is my lever arm. Lever arm in the sense that distance from the center to the outer face. Okay, this is my distance from here to here. So larger the lever arm, more will be a column to resist the moment. I'll write it here. Larger the lever arm, more will be column to resist the force. Okay, so that is why the larger diameter bar will try to keep it at the outer and the smaller one will try to keep it inside. Okay, so that is a normal practice what we adopt, and most of the structural drawings are done according to the same principle. Got it? So we have understood this also. Now we understood for the C1 F1 footing. We'll come to the C2 F2 footing. Got it? We'll come to the C2 F2 footing. Now in the C2F2 footing, what will happen? Again, for the footing, it is mentioned here. Here also you have to make use of a 10 diameter bar at 6 inches center to center spacing. Very good. And what they have mentioned here for the column, in this they have mentioned you have to provide a 16 diameter 8 bar. Very good. Okay, everywhere it is 16 diameter 8 bar. See, they have mentioned it here, and it is 16 diameter 8 bar. Okay, so always remember hash, and next to that the number which comes, it indicates the numbers, and after that whatever number they are putting, that is your diameter of a bar. Sometime you may get confused that 8 diameter bar of 16 number. So practically 16 number of reinforcement bar cannot be placed in the column unless it's a huge column. So here the basic understanding what we need to have is we need to provide a 16 diameter bar of 8 numbers. So you can see 1, 2, 3, 4, 5, 6, 7, 8, and all these 8 bars are of 16 mm diameter. Got it? So this is how you're supposed to understand the column reinforcement. Now come to the column lateral ties. So we know what is lateral ties. In the beams we call it as stirrup. Now coming to the lateral ties, they have shown it here. So in this particular column, you have to provide one master ring. This is how the master ring, and after that you have to provide another ring, something like this. Got it? Yeah. Similarly, here also you have to do the same thing. The difference between this and this is the master ring remains the same. Here also you have to provide the master ring. In this column also you have to provide the master ring. After that there is only one link here, but here he has given two link. Okay, so here they have given the two link, and this is how we are supposed to do it. Yeah. So actually this cannot be a two link because practically it's not possible to give a two link. Yeah, practically it's not possible to give a two link. So yeah, so it is something like this. Yeah, so I'll tell you what exactly has happened here. This shouldn't have been given. This is not to be understood. So this is the right one. Okay, see, sometimes what happens in the drawing, there will be a mistake due to a draftsman error. So we should be in a position to understand what practically it is going to happen. So this is the correct way. Now to put it in a better way, I'll explain it here. See here, what we are supposed to do. I'll take my first string now. Yeah, so my first string will go from here to here. Okay, here I'm going to do it in this way, and after that the second ring what I have now, it will go from here to here. So this is how the connection has to be done. Okay, so this is how we are supposed to do it. So that is why they have given it here in this way. That is why they have shown two rings here. But in this case, what has happened? In this case, yeah. So in this case also same thing they have given. Again, what they have shown is from here to here you have to provide one ring, and from here to here you have to provide another ring. So this is how the ring has to be provided practically on the side, and that is the right way to be done. Okay, again I think here he has shown two rings here, but practically what you're supposed to do is one ring will be connecting from here to here, and the second ring will be connecting here to here. Because see, one thing you need to understand, if I provide one ring completely in this way, then there is no meaning in providing another ring like this, right? There is no meaning in providing another link only for this portion. That means in this portion you are providing a link two times. So practically that is not possible. So the right option is this only. That is, first you provide a ring from here to here, one option, and then the second ring you connect again in this way. So this is the right way of doing the column lateral ties. Yeah, got it? How to understand the plinth beam layout, and we'll try to see that. Okay, so right now I'll take you to the plinth beam layout. So this is how the plinth beam layout is given. Yeah, so how do you put the plinth beam layout? For that we need to understand. Okay, we have a columns everywhere, right? So whenever we put the plinth beam, we should make sure, I'll write it here, the first step, always we should make sure that we are connecting column to column, connecting, yeah, connecting column to column. So what do you mean by this? That means whenever I put a beam, my main intention is to connect the column to column, or you can say tying of column. Okay, it's called as tying of column, or you can say connecting column to column. So that means now I have a column here, so I need to connect this with a beam. Okay, so I'll do it in this way quickly. So let me take one color. Yeah, so I'll connect this. So this is one beam for me, right? Again, I have a column here, I'm going to connect this with a beam. Got it? I have a column here, I have a column here, I connect this with a beam. So this is a typical way of drawing a plinth beam. Of course, you have to do it in the AutoCAD, but anyhow, basics are basics. We'll try to understand the basics. Then doing it in AutoCAD is not a big deal. Again, from here to here, I'll connect with a beam, and from here to here, I'll connect. Of course, I have to do in this way, and then from here to here. Got it? So these are the fundamentals you need to understand whenever you put the plinth beam layout, or whenever you do a plinth beam. This is a basic understanding we are supposed to have. Again, I have a column here, I have a column here. So let me put a beam here, and I have a column here. Let me put a beam here. Got it? Yeah. Now I'll make use of a different color just to differentiate. Now again, from here to here, I'll connect with the beam. Okay. I'll connect from here with a beam. I'll connect here from a beam, and from here to here, I'll connect with the beam, and I'll connect a beam. See, wherever you have column, you have to connect that with a beam, and that is the main logic. Again, I have a column here, connect that with a beam, and of course here also I have, so I'll connect that with a beam. Got it? Again, of course, we are supposed to do it here also. Yeah, good. So this is how a plinth beam layout looks. So this is a basic understanding what I have done, and for the same drawing, we'll see that how the structural engineer has done that. Now you can give the naming to this. Now naming can be anything, but the usual practice what we follow is that we'll start from left to right, the naming, and then from bottom to top. So this is a typical pattern we are supposed to follow when we write the names for the beam. Again, it all depends. You can even follow right to left, you can even follow the top to the bottom, but most of the engineer prefer left to right and bottom to top. So what do you mean by left to right and top to bottom to top? That means I'll give a name to this. I'll write this as PB1. That means plinth beam 1. So I've started from the left. First, I'll finish the horizontal beams. Again, where is my horizontal beam? So my next horizontal beam is here. This is vertical. This is horizontal. So I'll give this as PB2. Got it? It can be anything. I'll give this as PB3. I'll give this as PB4. I'll give this. Okay. I did one mistake. Actually, this is PB1. This is the second horizontal, right? Because this is next to that. I'll quickly change it out. So what I'm supposed to do is, yeah, let me quickly change them. So this is PB3. Okay. This should be PB4. This should be PB5. And now I'll write here PB2. Got it? PB2. So PB1, PB2, 3, 4, 5. We don't have any horizontal beams here. I'll give this as PB6. PB6. This will be PB7. This will be PB8. This will be PB9. That means plinth beam 9, and this will be my PB10. So all my horizontal beams I have covered. I'll go to the vertical. So vertical, you have to start from bottom to top. Yeah. So where is from a bottom to top? This is my bottom, isn't it? And this is top. So I'll give a name to this. Again, I'll go from left only. You can start even from here also, but we are following this left to right and bottom to top. So again, from the left side only, I'll start. So this becomes my PB11. This becomes my PB12. This becomes my PB13, and then okay, this is PB13, this is PB14, PB14. This becomes my PB15, PB15. This becomes my PB16. Okay, I should have used a different color. It's okay. PB16. This is PB17, and this is PB18. Yeah. I'll change the color to that. Okay, so PB11, 12. Got it? So this is a typical way we try to name the plinth beam. Now we'll see what exactly the structural engineer has done. Now you can see it here. Whatever I've done, no, the same thing the structural engineer has done it. Provided you can see here it has come PB18. This is PB17. We also have named it as PB18 and PB18. Okay, PB17. And then you can see we started from here, isn't it? PB1. And again, you can see this is also PB1. Then we have given PB2, this is also PB2. Then he has given this as PB3, PB4, and PB5, right? So I'll try to delete it out once, and then we'll go there. I'll delete this. Yeah, now you concentrate here. See, PB1 is given. Then he has given this as PB2, PB3. He has given this as PB3A. That also you can do, but you can give it as PB4 also, no issue in that. Then this is PB4 he has given. And again, he has come here, after PB4, he has named this as PB5. Okay, we missed this one beam. Yeah. I should have done one beam here. No issues. And we are learning. Actually, what happens from this is a place where your staircase starts, right? So always remember, wherever your staircase starts, isn't it, you have to give one beam there, so that what will happen, you can take the double bar from here. Okay, we'll see what is double bar. Okay, just try to understand. So this is a, you can see it here, no, leave double bars at so and so. We'll come to this a bit later. So from here your double bars will come, and from here entire load of a staircase will be transferred to this particular beam. So that is why we have to give one beam here. I had missed that beam, it's okay. So PB5 and PB6, PB7, PB78, PB8 and PB9. Then you see has come here PB10, PB11, 12A and 12, 12, 12A, then 13, then 14, 15, 16, 17 and 18. Got it? So this is a typical way of doing a plinth beam layout, and this is a typical way of doing a plinth beam frame layout. So whichever drawing you take from here onwards, this is the usual thing what we follow, and I hope you up to here your concepts are clear. Now what they have done is they have given a name to this. I mean the sizes, we give only PB1. So what these people have given, they are told that the size is 9 inch by 18 inch. This also 9 inch by 18 inch. Everywhere it is 9 inch by 18 inch. Now the question is that how did they tell that this is 9 inch by 18 inch? So there is no such thumb rule. So what we usually do is that through our experience, we can go with this logic. Otherwise, you can start to give the size of your beam right from 9 inch by, for if it is a residential or a commercial, you can give 9 inch by 15 inch beam size. That is 9 inches of width, 15 is the depth of your beam. And you can try to do the analysis with help of a ETAP software and all. And if you feel the load coming on that is sufficient enough to take care of that, you can proceed with that. Maybe here they might have tried with 9 inch by 15 inch, and they might have found that some of the beams were failing. If you had taken my ETAP course, or if you had taken my earlier drawing reading course, you have shown you how the beams load will be applied and all. Here we'll not try to do the same thing here, since our main intention will be try to see the different drawings and the advanced drawing. So they might have done that, and they might have, I mean, few of the beams might have failed. So that is why the next size is that always we try to increase the depth and not the breadth of the beam most of the time. So they have gone with a 9 inch by 18 inch, and that is why you can see everywhere it is 9 inch by 18 inch. Just in case even 9 inch by 18 inch was failing, they could have tried with 9 inch by 21 inch. But usually for the plinth beam and all, we don't go with the 9 inch by 21 inch, since only the wall loads are going to get transferred here, and no slab loads are going to come, since it's at the plinth beam level, provided there is no grade slab. Got it? So this is a typical idea you need to understand whenever you do the plinth beam framing. Got it? Yeah. So I think most of the things I've covered here about the sizes and all. And yeah, so that was all about the plinth beam layout, and you can see all the sizes. Now sometimes what happens, usually in the plinth beam we don't try to vary the size. That means you see everywhere we are given a 9 inch by 18 inch, right? What we could actually, this 9 inch by 18 inch is actually not required. Let us say somewhere at this place 9 inch by 18 inch is not required, or let us say somewhere here your 9 inch by 18 inch is not required. 9 inch by 15 inch was sufficient here. So usually what we do, out of, we see the majority of the beams. Let us say, I'll give a small example. See, let us say we have 18 beams here, right? We have 18 beams, because PB18, let us consider we have 18 beams. So in 18 beams, let us say 14 beams you require a size of 9 inch by let us say 18 inches. Okay, and let us say the remaining four beams you require a size of 9 inch by 15 inch. So for these four beams, we don't try to change the size, because why? Doing it on the paper is very easy. I can do it directly on the paper and write and give it. But the person working on the side, it will be difficult for him, because he has to see the drawing. He has to be very careful while doing the execution. And if you do it for 9 inch by 15 inch, again, you have to cut the shuttering board, because 18 inch shuttering board you have to put for the plinth beam layout. I mean, for preparing a plinth beam. Again, if you want to prepare this 9 inch by 15 inch, again, you have to cut the board, or accordingly, you have to make the size. So keeping execution point of view, usually for the plinth beam, what we try to do, even though there is no requirement in some of the beam, this size is not required, we try to keep all the sizes uniform. So that is why practically whenever you see the plinth beam layout, most of the cases I'm telling, there is no hard and fast rule that same thing has to be implemented. But most of the cases what we do, we try to keep it same even though there is no requirement. So that is why you can see the same has been reflected here. Everywhere we have kept it as 9 inch by 8 inch. Maybe here it was not required, but still we have given it. It's okay for us, because we always want to be a bit economical, and also to be on the safer side, and also keeping execution point of view to make the things easier for the executing engineer. I mean, for the site engineer, we try to do all these things. Yeah. So again, now coming to this part. So I explained you about the double bar. If you want, I'll be showing you about the what is double bar. Okay. already, if you have taken my site engineering course and the drawing reading, I've shown you many number of times what exactly a double bar is. From this beam, we try to insert all this rebar. So these are called as double bar. Here we have to make use of a 12 diameter bar at 6 inches center to center spacing. That means the distance between these two rebar has to be 6 inches, 6 inches, 6 inches. And this is your 12 diameter bar you're supposed to use. Got it? So this is how the entire plinth beam layout looks, and that is how it is. Yeah, we need to understand one more thing here. You can see here, he has given a note here. The blue one indicates beam top at below ground level, and the pink one indicates beam top at plinth level. So actually there is a difference in the ground level here. The one which is blue color, like you can see it here, this is blue color, right? The beam is blue color. All these blue beams, whatever you are putting out, that means the outer, they are at the ground level, at below the ground level. Okay, I'll show you it in the next lecture also what exactly it looks. And beam at top, beam top at the plinth level, whereas this internal beams, this beam, this beam, this beam, and this beam, because they are pink in color, this is also pink. This being the top of this beam is at the plinth level, whereas the top of all these beams is at the ground level. So that means there's a level difference between these two beams. That means if I put it in a better way, let us say this is your beam at the outer one at the ground level. Okay, and the one which I'm showing you, okay, I'll go with the same color. So this is blue color, right? And this is pink color. I'll take a blue color first. Yeah, so this is a ground beam. Okay, and the one which is pink in color, it is at this level. Yeah, this is pink, so this is that level. Got it? So this is the level difference what we have. Okay, this is the level difference we have to maintain. So this is the top of your plinth beam, and this is your top of your plinth beam, and whereas this is your top of your ground level. This beam will come at the top of your ground level. Anyhow, in the next lecture I'll show how to understand the plinth beam reinforcement details, and this is a completely a new thing which we have not seen in our earlier drawing also. Okay, so what I'm going to do, first I'll play a video of a reinforcement, or I'll be okay, first let me start with the drawing itself. I'll show you the drawing first. Okay, so this is a schedule of RCC plinth beam, all these are the beams numbering. Okay, like PB1, PB2 we had seen. So these are the beam, they have done the grouping like PB1, PB2 and PB9. It's a one group, and the size is 9 inch by 18 inch. PB3 is another group which is 9 inch by 18 inch. Then we have PB3A, PB7, PB78 and 8. This is 9 inch by 18 inch. PB4, PB12, PB16, it is 9 inch by 18 inch. So in this way all the grouping has been done and the sizes are given here. Now the important thing for us to understand is the reinforcement details, right? You can see all the steel has been placed here. So this drawing up is a bit difficult, not difficult, you need to understand and you have to apply your logic, that's it. Yeah, so now just concentrate here. I'll go with the bottom steel first. See this is the bottom steel I have, and this much part we have it as a top steel. Okay, now when I say bottom steel, always you have to remember the bottom straight. This is the first thing, it is a straight bar you have to remember, and then you remember the curtailment bar. Okay, in the same way when I say of top steel, first remember the mid span, and then you can go with the extra steel and the extra steel at the support, right? So I hope this much is clear. First we'll understand this particular beam, that is PB1. Okay, so for PB1, what is the size? It's a 9 inch by 18 inch. Very good. Now coming to the steel reinforcement, first look at to the straight bar. What is a straight bar? What is that mentioning about? Straight, your straight, it is in the bottom. Okay, so you have to provide a 16 diameter 2 bar straight in the bottom. Very good. And curtailment bar in the sense which you are going to do the curtail. I'll show you practically what curtailment bar is all about. I'll just play this video. Yeah, so you can see one bar here. Yeah, you can see one bar here which has been curtailed. See, the bottom two bar are going straight. This bar is going completely, and the one which is at the back side, that is also going completely. Whereas the one in the middle, it is curtailed. Curtailed in the sense it is cut. It is going only up to this distance. So this is called as my curtailment bar. Got it? So that is why in the drawing it is mentioned. In the mention that curtailment bar you have to provide a 16 diameter 1 bar, right? I hope this much is clear. Now coming to the top steel, always look for the mid span first. Mid span 12 diameter 2 bar. That means practically on the two bars have been running completely. That means This is one bar which is going completely at the top. Similarly, you see one more bar here which is going completely. So this is a straight bar what we denote, and it is called as top straight bar. Okay, yeah. Now it is mentioned here midspan 12 diameter 2 bar. Now there is something written here, extra steel at continuous support and extra steel at end support. Okay, so to understand this, I'll just run the video and I'll show you. Okay, before that I'll show you a drawing only, so through drawing we'll be able to understand. Now what do you mean by extra at the end support and the continuous support? So for that we'll take a plinth beam layout. Now for example, let me consider this particular beam and just concentrate here. It's very simple. Okay, just concentrate on this beam. Okay, so for this beam, how many columns I have? I have one column here and I have another column here, right? Now when I consider this column has a beam going in this direction also, right? If I take this particular beam column, I have a beam running in this direction. Similarly, if I take this particular beam, I don't have a beam running in this direction. See, forget about this vertical. Right now I'm looking at the horizontal part only, because I'm considering this two column. That is why I'm considering this. I'm going horizontally. Okay, so here if I consider this column, I have a beam running in this direction, whereas if I consider this column, I don't have any beam running in this direction. So when I put the reinforcement here, since I have a beam running here, this becomes my continuous. This becomes my continuous. For this column there is a beam which is running in the left direction. It's called as continuous. So that is why you can see it here. So initially it will take some time for you to understand. So what is written here? Extra steel at continuous support is written. Extra steel at end support. Again, to put it in a better way, we'll go in this way. Now for this column, this is a continuous, so I can say this is extra steel on the left. Similarly, for this column I don't have a beam running in this direction, so this is my end condition. This is my end support. Like if I go back, so it's written extra steel at end support. So for this column I don't have any beam here, so this becomes my end column. If I have a beam running, it becomes my continuous column. Got it? I hope this much is clear. Now for this I'll show you a practical video only, and then we'll try to understand that. So I'm running the video once, okay, and I'll pause at one particular point, and you have to tell me which is a continuous support and which is a end support. So let me go a bit forward. You just see the video and then I'll come a bit and explain you about all these things. Now for example, if I consider this particular beam, okay, if I consider this particular beam, see, I have a column here, I have a column here. I'll take the same beam and I'll show through drawing. See, initially it may take some time for you to understand, but it's very simple. We'll try to understand. So right now we are looking at this particular beam. Okay, I'll show where it is exactly. Yeah, okay, so this is that we are looking PB6. Okay, now tell me, I have a column here, I have a column here. So for this beam, which is my end support and which is my continuous? So for this particular beam, this column is the end column, because beyond this you don't have any beam running, so this is my end column. Good. Similarly, for this beam I have a column here, but again in this direction there is a beam running, right? So that means this particular column is a continuous column for me, right? I hope this much is clear. Now for the same PB6, check out what is the reinforcement given. I'll go to PB6 because this is PB6 written here. I'll go to PB6. Let me find where is PB6. Yeah, my PB6 is here. So this is PB6. It's a 9 inch by 18 inch. And what is given in the bottom steel for the PB6? I'll write in this way. Concentrate here. Yeah. So what is given in the bottom steel? You have to provide a 16 diameter 2 bar in the bottom. We'll see practically. Can you see a 16 diameter 2 bar has been given in the bottom? You can see a 16 diameter 2 bar has given in the bottom. Okay, and then you have to provide a 16 diameter 1 bar, that is a curtailment bar. That means bottom you have to provide a 16 diameter 3 bar, and you can see practically here 1, 2 and 3 bars have been provided, whereas this bar, the middle bar, is a curtailment bar. Okay, when I say curtailment bar, it is not running fully, it has been stopped from here to here. Okay, this is your curtailment bar. Got it? Similarly, if I go to the top steel now, yeah, For PB6, if I go to the top steel, top you have to provide a 12 diameter 2 bar. It is in a mid span. That means you can see a 12 diameter 2 bar here. So 1 bar, this is 12 diameter 1 bar straight, and this is 12 diameter another bar. Okay, this much is understood. Yeah, now one thing which we are supposed to understand is this point. PB6, I'll come here. See what is written: extra steel at continuous support and extra steel at end support. Extra steel at continuous support and extra steel at end support. First we'll go with the extra steel at end support. Okay, you have to provide a 12 diameter 2 bar. So where is the end support? This is my end support. Agree with me, because beyond this you don't have a beam, and same thing we had seen in drawing. So you can see a 12 diameter 2 bar given here. You can see 1 bar. Similarly you have provided another bar here. So this is a 12 diameter 2 bar which has been stopped here. Similarly, if I come to the other side, yeah, again extra steel at continuous support. That means, so I have a column here, but there is a beam going in this direction, so this becomes my continuous support now. So what is there in the drawing? For that, again there you have to provide, that is extra steel at continuous support, you have to provide a 16 diameter 2 bar. So practically you can see it here. Yeah, so practically you can see we have provided a 16 diameter 1 bar. This is one, and this is another bar. You can got it. So this is how we are supposed to understand the drawing. Now one thing might have come in your mind, that you told everything, but to what distance we are supposed to keep all these things, like from here to here what is the distance, from here to here what is the distance, that we'll try to see a bit later, right? First we'll try to understand all the fundamentals through this. I hope up to here your concepts are clear. Now I'll run all this video, and then I'll stop at one particular point, and we'll take that as an assignment, and you have to tell me how it looks. Okay, so just see. Again you can see that continuous, right? See how it is, how it has been given. I'll stop at this particular video, right? I'll stop here. Right now the beam which we are looking, no, I'll show you the same beam on the drawing. Right now we are at this level, so we are looking at this particular beam. We are looking at this particular beam, that is PB13. We are looking at this particular beam, that is PB13. Now we'll try to see the reinforcement what is given in PB13. So I'll go to PB13. So my PB13 is here. Okay, PB12, PB13 is here. What all is given, just read out. I'll start with the bottom steel now. Bottom steel I have to provide a 16 diameter 2 bar. We'll see practically whether 16 diameter 2 bar has been provided. Exactly, we can see a 16 diameter 2 bar here. This is one 16 diameter bar which has gone completely, and the one on the other side, this is my 16 diameter 2 bar which is a straight bar. Okay, now again come back. Again what is written here? Again come to the curtailment. In the curtailment you have to provide a 16 diameter 2 bar as a curtailment bar. 16 diameter 2 bar is a curtailment. So can you see a 16 diameter 2 bar has been given here in the middle portion. So here one, and next to that, yeah, let me go back. See here, this is one 16 diameter 1 bar, and then again behind that we have given another bar. This is 16 diameter 2 bar. Got it? Similarly I'll go to the top bar. Bottom is done. I'll go to the top now. So now coming to the top steel, first we'll have to see the mid span. In mid span you have to provide a 12 diameter 2 bar. So we'll see, and the mid span whether 12 diameter 2 bar has been provided. Obviously you can see this is 1 bar, and another bar is here outer. Okay, so this is my 12 diameter 2 bar which is going continuously. Got it? This much is clear. Yeah, now for this beam you tell me which is a continuous support and which is a end support. Now for that what we need to understand, I'll go to the drawing again. Yeah, you see here. Okay, this is that. So I have a column here, I don't have any beam running in this. That means this is my end beam, this is my end column or the end support. Similarly I have a column here, I don't have a beam running in this direction, so this is also my end support. That means here both the condition are end. So if both are end, then what I'm supposed to do, I just have to look here. So I have to look end extra steel at end support. So that is why you can see a dash has been put. Why? Extra steel at continuous support there is nothing, because there is no continuous support. Both the side you don't have beam, that is both are end support. So again in both the end support you have to provide a 16 diameter 2 bar. So practically you can see here a 16 diameter 2 bar has been provided. So this is one 16 diameter bar, and this is another 16 diameter bar. Got it? Similarly here also we have provided a 16 diameter 1 bar. Okay, and here also we have provided a 16 diameter another bar. Got it? So practically this is how you are supposed to understand, and this is how the drawing has to be understood. So I hope up to here you enjoyed it and you got an idea exactly how to understand the drawings and all. Right now I'm showing you all the beams and all. The same concept has been adopted, and for the same building I'm showing you the structural drawings. Again you can see it here also. See it here, top to steel, bottom, then the bottom curtailment. This is the left extra, this is the right extra. Yeah, right. So again this is how the reinforcement is given. You can see the top left extra, bottom curtailment, and top right extra. So again I'll play the video here. Yeah, so right now I'm at this particular beam and I'll show you on the drawing where this beam is all about. I mean the location of this beam. So if I go to the plinth beam layout, right now I'm at this particular beam. Okay, so I'm see, because here I'm getting a staircase and this is that portion right now where we are, and we are at this particular beam which is called as PB2, right? So this particular beam is PB2. Now I'll check the reinforcement details for this PB2. So search for PB2. So my PB2 is here. Again it's a 9 inch by 18 inch. So now come to the bottom steel. Okay, you have to provide a 16 diameter 2 bar. So practically you can see bottom, this is 1 bar, and after that next to that we have another bar. So this is a 16 diameter 2 bar, and then again straight is done, and yeah, PB2. Then curtailment is 16 diameter 1 bar. So you can see a curtailment bar here. So this is a curtailment bar which is a 16 diameter 1 bar. Okay, good. Now come to the top portion. Bottom is done. Now coming to the top side. So if I go to the top now, top steel, again in the mid span you have to provide a 12 diameter 2 bar. So where is my mid span? So this is the top is my mid span. So I have to provide a 12 diameter 2 bar. So you can see 1 bar which is gone completely, and this also gone completely. So this is your 12 diameter 2 bar. Good. Now you check the column. Okay, see I have a column here, I have a column here. So for this particular beam, this column is the end column because beyond this we don't have any beam running. So this is my end condition, end support. Similarly this column is also end condition because I don't have a beam running in this direction. See, we have a beam, this is not to be considered. You have to take the horizontal one. I mean it depends where exactly is your beam. Okay, so if you're not able to follow, still I'll go to the drawing part again. See here, now you can tell me. So here I don't have any beam running, so this is my end beam or end support. Again this is also end support. Since both are end support, so it's very simple. I have to look for which one. Extra steel at continuous support, I don't have to look here. So that is why you can see they put a dash here. Now extra steel at end support, which is a 12 diameter 2 bar. So practically what you're supposed to do, 12 diameter 2 bar, you can see one, and this is another. This is a 12 diameter 2 bar. End support on both the condition, on both the side it is end support against a 12 diameter 2 bar. In this way you have to take it. Got it? So I hope up to here your concepts are clear and you are in a position to understand this particular structural drawing. The main intention of taking this drawing was about the end condition. We should be in a position to understand what is end condition, that is end support and the continuous support. Okay, now for your understanding I'll give you one question here. Just tell me what kind of support is this for this particular beam. Now for this particular beam, this is my end support, whereas this is my continuous support, because for this column we have a beam on this direction, right? So this becomes my continuous. Got it? Similarly if I take this particular beam, this is my end, because beyond this I don't have a beam, but this is a column I have, but beyond this you have a beam, then this becomes my continuous support. Got it? So that is how it is to be understood. And we'll try to see one more thing here, that is about the level difference, which I told you that. So we'll see the level difference also. Yeah, so I'll just pause it here. See, you can see this beam is at this level, that is a bottom level, whereas this beam we have put it over the stone masonry. This is another level. So you got it? So this is your actually top of your plinth beam, this is the top of your plinth beam, and this is your ground level. Got it? So that is why I told you that at the time of discussion of the structural drawing, like it was mentioned, I'll take you to that drawing. Yeah, so what is written here? beam top at below ground level and beam top at plinth level. So right now we are standing here and these are the beams which we are seeing, and these 4 beams 1, 2, 3 and 4, and practically you see 1, 2, 3, yeah, 1, 2, 3, and this is the 4th beam. These are over the ground level, that is this will be my top of the plinth, whereas these beams, no, these are at the bottom level. Okay, that means the bottom in the sense these beams, all these beams you can see, no, yeah, these beams, yeah, sorry, these beams, okay, these beams. So these beams are blue in color. So what is written for the blue color? Beam top at below ground level, beam top at below ground level. So that means the top of this is at the ground level, below the ground level. Okay, see, which is my ground level? This is my ground level, the place where you can see the soil, isn't it? This is a ground level. Okay, now this beam is below the ground level, agree with me, whereas this beam is above the ground level. So this top level is my plinth level, got it? And once we do the casting, we start to do the laterite masonry work over this. So this is a practice what we adopt here, got it? So I hope up to here your concepts are clear. If you have any doubts, you can always ask in the comment section, or you can ask in the answer and question, so I'll be there to answer you out. Okay, anyhow, once we finish this, I'll be showing you the entire video of this once the plinth beam is also done. I think most of the things I've covered it here. Only the thing is few things, yeah, you can see the level difference here also. To put it in a better way, check it out here. See, this is your plinth level and this is your ground level. So this is your ground level what I have, and this is my plinth level. Again, for all these things they are given a cross section. Yeah, I didn't explain all these things, but anyhow we understood now how those reinforcement has been arranged. Already we have understood all the concept. So like I mentioned, we'll try to see the cross section of that. Okay, I mean the longitudinal view of that. So here they are mentioned how is a PB12A beam looking. So this is a table usually what we give. Sometimes it is quite difficult to understand through the table, right? You also might have found it a bit difficult to understand. So in that case, what people do is they give a small longitudinal section so that you get understanding of that. Now again, you just concentrate here. You can see the top steel being given here. So this is my top steel. Okay. Similarly, a bottom steel is also shown. Along with that, you can see a curtailment bar is also shown. I'll show that with a green color. So this is my bottom curtailment. Okay. And as mentioned it here, 16 diameter 2 bar, which is a curtail bar. And also this is my top left extra. I'll go with a different color. See here, it's written, this is top left extra, and this is your top right extra. Got it? So that is how it is written here, end support, and here also it is written, right? Yeah. Now, till what distance this is going to go? This top left extra, it will go up to 4 feet, and your top right extra, it will go up to 4 feet. That is from the center of the column it goes. So that much distance you are supposed to keep it. Got it? Yeah. Now, what all things is left out? Other than that, most of the things we have understood. Again, you can see here, this is for the stirrup. That is, you have to provide a 8 mm bar at 6 inches center to center support. Similarly, at the end also you have to provide a 8 mm bar at 6 inches center to center support. Whereas in the middle you have to provide a 8 mm bar, but center to center support is 8 inches. So what is trying to tell? For that matter, if I take one of the beam from here, I'll show you through one of the beam. Okay. Yeah. So in this particular project, they have not maintained that, but later when I went, I told them to change. But initially what they had done is they had kept all the spacing same. So what they are actually trying to tell is this center to center spacing has to be 6 inches, 6 inches and 6 inches. This is my left support. Similarly, this also has to be 6 inches, 6 inches, 6 inches and 6 inches. And now this is my middle portion. Here your center to center distance has to be 8 inches. Since what is the concept behind that? We know, because at the center your shear force will be less. When the shear force itself is less, no much steel is required, no much stirrup is required. If no much stirrup is required, we can increase the spacing. We know all those things, right? So that is the main concept. So now you don't see the difference here, because they had done a mistake on the side, that everywhere they had given 6 inches throughout, which is not the right way to practice. In the center you can increase the spacing. So that is why in the structural drawing, if I try to show you now, you see here support at 1/3 of a span and rest. When they say 1/3 of the span, that is near the support, you can see everywhere it is 8 mm bar only at 6 inches center to center, 6 inches, 6 inches, 6 inches. Whereas rest, in the sense the middle portion is called as rest. So it's written 8 inches, 8 inches, 8 inches and 8 inches. Again, you can see it here also. See here, this is a support portion. This is also support portion. This is a rest. Rest in the sense the middle portion, we call it as a rest. Here your center to center spacing is 8 inches. Here it is 6 inches and here it is 6 inches. Got it? Yeah. So now another thing is that Yeah, this curtailment length we have to find. Yeah, I'll tell you how to find the curtailment length. See, if you understand this curtailment bar, you can see it here, this curtailment bar. Yeah, so now we don't know the length of this curtailment bar, right? Here they are going to mention that at what length you have to curtail. It's written 0.7 into L1. So what is this 0.7 into L1? So to put it in a better way, let us say from this column to this column, the distance is 10 meter. I'm speaking in terms of meter, okay? So it is 10 meter. Now what is 0.7 into 10? Because 0.7 into 10, if I do, I'm going to get 7 meter, right? 7 meter. So that means practically the meaning of the curtailment is that from here to here, you have to maintain 7 meter distance. Got it? You have to maintain 7. Overall, it was 10 meter. Now only the middle portion will be 7 meter. Another 3 meter, in the sense 1.5 meter you leave from here, and 1.5 meter you are going to leave from here. Got it? So that is how we are supposed to do. Similarly, we can take another thing also here. Yeah. Now coming to the other part. So the top extra. Now come to the top extra. So top steel, they have written it here 0.33 into L1 plus L2. And here he has given 0.2 into L1. That means wherever you have a continuous support, no, there your extra steel has to go 0.33 into L1. Wherever you have an end support, no, there you have to go for 0.2 into L1. That means through a drawing only, I'll explain you. See now, for this particular beam, this is my end support, isn't it? Whereas for this particular column, this is a continuous beam I have. That means this is a continuous support, this is an end support. Now go to the drawing again. So wherever it's written extra steel at end support, that extra steel you have to give up to 0.2 into L1. That means practically, let us say from this column center to this column center, I'll take a distance as 15 meter. Okay, practically 15 meter is not possible. I'll take it, no issues. Now tell me what should be this distance from here to here. This from here to here, very simple. The formula is given 0.2 into L1. So my L1 is 15 meter. So try to do this 0.2 into 15. 0.2 into 15 comes out to be 3 meter. 3 meter. Very good. So this will be 3 meter. So this distance what I have, no, I'm going to write this as 3 meter. Change the color. Yeah, 3 meter. Similarly, now come here. So this portion I don't know. Again, this is my continuous. For the continuous, what the drawing says that for the continuous extra steel at continuous support, it is 0.33 into L1 plus L2. You don't have to do this L1 plus L2. Okay, it is actually L1 or L2, whichever is higher you have to take. You just remember 0.33. Okay, that is enough. So that means this was 15 meter. So do 0.33 of 15. 0.33 into 15. So tell me what is the answer you are getting. 0.33 into 15. So I'm getting a 4.95. So I can take 4.95 as 5 meter. You can round off it 5 meter. Okay. So that means practically from here to here, this distance, no, this extra bar what you have provided, we'll keep it as 5 meter from here. Got it? So this is the importance of that curtailment bar, and all those things will be mentioned in the structural drawing. So usually if you're lucky, they're going to give you everything. If you're lucky, they'll give you everything. Like see, they've given it here. From here to here it is 4 feet. From here to here it is 4 feet. From here you leave 3 feet. From here you leave 3 feet. And then you give this curtailment bar. Okay. So everything will be mentioned. Just in case if they don't mention, then whatever formula I thought, you know, I already have written it here. You can do the calculation and do it on the site. Okay. Because sometimes what happens, all those things will not be given. So we should be in a position to understand that. That's all. Okay. Now again, you can see here, it's a 14 feet 11 inch. So try to do this. Let me try to do it. I'll see. So 14.11 into 0.2. Yeah, so we'll do for this. Okay, to take it as an assignment. See, we know from this center to center it is 14 feet 11 inch. Now tell me, how did these people get 3 feet here? So very simple calculation we are supposed to do. So if I look at this particular beam, this becomes my end support because I don't have any beam running in this direction. So this is my end condition. For the end condition, what is the formula you are supposed to apply? So for the end condition, yeah, extra steel at end support, it is how much? 0.2 into L1, right? Because we are looking at the top steel now. So 0.2 into L1, that means 0.2 into what is L1, that is 14.11 I'll do. Okay, 14.11 inch it is. So if you do it 0.2 into 14.11, I'm getting 2.82. Or I can do one more thing. I'll convert this for our understanding. What I'm doing is that this 14 feet 11 inch, you convert this in terms of feet. So I'll quickly do that. Okay. Yeah. So what we can do is take this as 0.2 into 14.91. Try to do what is the answer you are getting. Tell me. Into 0.2. We're getting 2.98. So that is feet. Okay. 2.98 is a feet. And practically they are given 3 feet, because 2.98 you can take it as 3 feet. How did I get this 14.91? What I've done, 14 feet, my answer, my dimension is 14 feet 11 inch, right? I'm converting this 11 inch in terms of feet. So 11 divided by 12, because 1 feet is 12 inches. 1 feet is 12 inches. So I'm converting that in terms of foot. So 11 inch divided by 12, have done it. So 11 divided by 12, I'm getting 0.92. This is 0.92 is a inches. Sorry, 0.92 is a feet. Okay. I hope I'm able to convey you. So that's it. Very simple. So I'll add 14 plus 0.92. Try to do that. I'm getting 14.92. I've written 14.91 here. It's okay. Got it. In this way you're supposed to do, and we have got the answer. Now come to this portion. How did you get 5 feet here? Again, very simple. So for this particular beam, this is a column what I have, but I have a beam going in this direction. Then this becomes my continuous support. And for the continuous support, you have to use 0.33, right? You have to use 0.33. Now try to apply this formula of 0.33. That means 0.33, multiply this by, what is the distance? 14.91. Okay. So if I do that, 0.33 into 14.91, I'm getting 4.92. That is 4 feet and 9 inches is what you're getting. Okay. Or we can say it is 4 feet 10 inches, I can say. So here, instead of giving 4 feet 10 inches, practically what the people have done is they've given 5 feet here. Can you see? 5 feet answer has come. So in this way, you have to apply that formula, and based on that, you're going to do. Now all these things have been done by using the same condition what they have given it here. Similarly, now coming to the cross section. Now this is a cross section for that. Okay. So what is this cross section for this particular beam? The same cross section they have shown it here. So you have to check where they have cut it. Yeah, you can see here. So this is a beam what I have, right? And they have cut a section here. If I cut a section here, then this is how it looks. So you written cross section at XX, then this is how it looks. It's a 9 inch by 1 feet 6 inches the size of your beam. Okay. And you can see a 12 diameter 2 bar at the straight you have to provide, and then 16 diameter 2 bar at the end support you're supposed to provide. And then again bottom you see 16 diameter 2 bar will go straight, and 16 diameter 2 bar will be a curtailment bar. Okay. All right. And then again you have to make use of a 8 mm bar at 6 inches center to center spacing. Similarly, they have given it for the section YY. They're given it for the section YY. See, when you look at the section, it will be showing in this way, because it's a dot dot. This dot represents, the green dot represents the rebar. Okay. But how much curtailment length you have to provide and all, no, those things you have to see from the longitudinal view only. Here, from here only, you are going to get an idea what is that curtailment length and all. Now I'll go for the section YY. Again, for this beam, you see here they have drawn a section YY. They have cut a beam, and that is how it is shown it here. That is how they have shown it here. Okay. So what we can do is that we can try to do on our own. So can you put the cross section of this? It's very simple. See, when I cut a bar here, I'm going to see my top steel. I'll do it for you. We'll see. So this is my beam now. Okay, good. So I'll quickly draw all those things. So I can see the top bar. If I cut a section, I can see a top bar, which is at top bar. It's a 12 diameter 2 bar. So I'll quickly draw a 12 diameter 2 bar. This is one. This is another 12 diameter 2 bar. Then I can see this steel also. So it's a 12 diameter 1 bar at the end support. At the end support, it's a 12 diameter 1 bar. That means it will be here only. It will be in between this. Okay. This is my 12 diameter 1 bar. Similarly, come to the bottom. Bottom, you have to provide a 12 diameter 2 bar. So this is one, and this is another 12 diameter 2 bar, right? So this is how a cross section looks if I cut it here. And let me cross verify whether the person has done the same thing here or not. Yeah, exactly. You can see whatever I taught you, the same thing they have done. These two are red color, which is a 12 diameter 2 bar, and the middle one is your 12 diameter 1 bar at the end support. You can see it here. And bottom, you see what I have done. I have given 12 diameter 2 bar, that is a straight 1 and 2. And of course, this 8 diameter bar at 6 inches center to center spacing is mentioned here. So of course that will be given. It will be shown here. Okay. It will be shown here, and same thing you can do, or it will be written here also. If I cut a section here, it's written 8 mm bar at 6 inches center to center at the support. The same thing they have given at the section YY, that is 8 mm bar at 6 inches center to center spacing. Got it? So I hope you have understood it. Same thing is here also. Just try to understand this. Just take a screenshot of this or something like that. Try to see it, and same cross section they have given it here. Take an assignment. You take this as an assignment and try to put a cross section for this CC. I'll quickly do this. You pause my video and you do it on your own. I'll show you how it has to be done. I'll draw a beam. Okay, I'll draw in this way. I'll draw a beam like this. Okay, now I've cut a section here, right? So that means this top steel will be visible. What is the top steel now? For that I have to check here. What is the top steel? So this top steel is actually 12 diameter 2 bar. That is fine. So I'll draw a 12 diameter 2 bar. So this is one 12 diameter, and this is another 12 diameter. Then again, this bar is also visible. It's a 16 diameter 1 bar. I'll take a different color. So this is my 16 diameter 1 bar. Come to the bottom portion. Bottom, we are providing only a 16 diameter 2 bar. This is my bottom. See, this is my bottom. This is my bottom bar. Okay, it is shown here. That is, it's a 16 diameter 2 bar. So that is why I'll do 16 diameter 2 bar here. Yeah. So this is 116 diameter, and this is another 16 diameter. Of course, I have to put a stirrup. Let me put a stirrup also for that. Yeah. So this is a stirrup what I have put. And what is a stirrup? It's a 8 mm bar at 6 inches center to center spacing. I'll write it here if you want. It's a 8 mm bar. Okay. At 6 inches center to center support. I'll write in this way, hash. It's understood that you have to provide a 8 diameter bar at 6 inches center to center spacing. Got it? Now we'll try to cross verify whether the same thing has been done here. Yeah, the same thing has been done. See, 12 diameter 2 bar, 1 and 2. The red one is my 12 diameter 2 bar. This one is my 16 diameter 1 bar, the white one. Bottom 16 diameter 2 bar, 1 and 2 is my 16 diameter 2 bar. And it's a 8 mm at 6 inches center to center spacing. 8 dia bar. I mean, it's a 8 diameter bar at 6 inches. So 8 diameter at 6 inches center to center spacing. And practically all these are your stirrup, how it's going to look. Okay, all these are 6 inches, 6 inches, 6 inches, and 6 inches. Right. So I hope I was able to convey most of the things, and we have understood this entire layout for this particular building. After this, we'll try to take the staircase part, how the staircase drawing looks. And that's how we are going to finish this particular building. Right now, these are the drawings what I have with me. And whenever I get the slab layout for this, we'll try to add that in the next lecture. Right now, I have another staircase, because right now this particular project is happening on the site practically. So whatever drawing I have got so far, that is a staircase drawing I have. I'll explain that. And future, when I get my slab layout for the same drawing, I'll show you the slab also. How the staircase plan looks and how it has been worked out. So again, I'll take you to the drawing. So first we'll go with the staircase plan. Okay. So this was a revised plan what we have got. Okay. I'm taking for that. So it's a written revised ground floor plan. And in this portion, we are getting a staircase, right? And of course, we had given a beam here. And from this beam, you are going to put the double bar. So I'll show you the plinth beam layout also. So in the plinth beam layout, this is how it was given. See, actually, the plinth beam layout was not revised, right? So actually, this double bars will start from here only. Earlier, this was our staircase. But like I mentioned, we've taken the staircase from here. Now, instead of this particular beam, no, this double bars we are going to insert here itself. Okay, this much is clear. Yeah, now we'll go to the staircase part. So see, this is how a staircase is going to look. You can check from here. See, this is a plan what they are given. This is a beam I have. I have a beam here and I have a beam here. So from here we are going to start it. Okay, and see, this is how it looks. So this is my plinth level. From here, my first step is going to start. Okay. So in this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is 11. And what is this? This is called as thread. Okay. This is called as thread. And this height is called as riser. So this rise you have to keep 6 inches. and thread you have to keep 11 inch. So it will be mentioned in the drawing. You can see number of steps there are 23, thread it is 11 inches, and rise it is 6 inches, and waist slab thickness. What is this waist slab? You can see a slab here. So this is called as my waist slab. So this thickness you are supposed to keep it as 6 inches from here to here. Okay. Yeah. So from here to here, this is my waist slab. This much is my waist slab. So this thickness you are supposed to keep it as 6 inches. And rest all things are very simple. And we are going to get the floor to floor height here. So from this plinth level, from the top of the plinth beam to the top of this ground floor, okay, this height is 11 feet 6 inch. Again, from the ground floor slab to the first floor slab, it's the top. Okay, see, this means that you are standing on the ground floor. From there to the top of the first floor where the slab is put up, not from the inside, outside, including the slab thickness, my floor to floor height is 11 feet 6 inch. Similarly, first floor to terrace floor, from the first floor to the terrace floor, the height is 10 feet 6 inches. And the last is your terrace floor. From the terrace floor to the last, that is your parapet or the mumty level, it is 8 feet 6 inches what we have. And this is a typical staircase plan what we can see. So you are taking a stair from here. You are going to do a landing here. We have a toilet in this portion because you can see the drawing here. In this drawing, there was a toilet given, isn't it? So this much portion we have utilized it for the toilet. This is for the toilet, and this is your landing slab. Okay, and you can see the same thing here. So your from here it is going, and this is a landing, and this is your toilet portion. Okay, similarly, this is my first flight. This is my second flight. Again, this is a landing here. Again, you're taking a flight from here. This is a landing. This is here also we have a toilet in the ground. I mean, this is my ground floor. Okay, that's the mid landing level, and this is my first floor level. Okay, yeah. And again, from here you are going to take a staircase, that is the next flight, and you'll reach to the first floor. And from here you'll take to the next flight, and you'll reach to this mid landing. And from here you are going to reach the terrace floor. So this is how a staircase plan is worked out, and this is how we are supposed to understand the plan. So only the thing what we have to understand is the floor to floor height we get from here, which is 11 feet 6 inch, which we usually keep for commercial building. If it is a residential building, home and all, you can go with a 10 feet. And here, since it's a commercial building, we have gone with the 11 feet 6 inches. Got it? Yeah. So other than that, most of the things we have understood. Yeah. One more thing you need to understand. See here, we have given a slab here. Okay. Why is this? Because it's a toilet portion, right? So in the toilet portion, you have to give a sunk slab. So this is a slab what we have given. From the top of a plinth beam to this bottom, you have to keep it as 4 feet 6 inches. Sorry, 4 feet 3 inches. And from the top of the plinth beam to the top of your mid landing, that is the first flight, it is 5 feet 6 inches. So it's a sunk portion, because when you keep Indian toilet and commode and all, Western toilet, you have to take your plumbing lines. So that is why, in order to take your plumbing lines, we have given this sunk slab. Similarly, this is also another sunk slab what we have. Okay, since we have toilet, we are going to give the sunk slab. Yeah. So I think most of the things I've covered from here, the staircase part and all, and there is nothing much to explain here. Most of the things we have seen, only the double bars we have seen, it will come from here, because this we have shifted here, right? So that is why your double bars will be here itself. Yeah. We'll be taking up this particular building. So this is a building what we are going to take. So it has a basement floor here. So this will become my ground floor, then the first floor, second, third, and then the roof portion for us, right? And this much is my lift portion, and this is how we are going to see for this entire building. So I'll show you one of the drawing. We'll start with the basement floor. So you can see it here. It's written basement layout plan. So usually basement, we are going to use it for car parking and all. And now you can see it here. So to put it in a better way, yeah, see right now, whatever you're able to see it here, right? The same thing. This is how the building looks from the front side. You can see this much portion. This is for the lift portion. And you can see you have a staircase here, and then another staircase in this direction. Similarly, if I switch to the main drawing, you can see we have a staircase here. And then actually there is one more staircase here. It's not shown because the drawing got revised later. Because when you, like I mentioned, whenever we work in bigger buildings and all, if it's a G+1, I mean, if it's a G+4 building, every time the plan keeps on changing. Sometimes the client says that, okay, I need a staircase here and a staircase here. Maybe after some time, what will happen, the plan will change, and the staircase may, you may shift the staircase from here and from here to here. So that usually happens because you can change the plan, because the thing is that plan, when I say you can change the plan, because all the staircase and all we are going to do it later, right? Once you put the slab of before the casting of a slab, you are going to put the staircase, right? But whereas we cannot change the column locations and all, so that is why the first thing is that we are going to fix the column, and after that we try to do all the other things. So whenever we get a revised drawing, the chance of column getting revised is very less, right? The plan may change, but other things remains the same. Yeah, so I hope up to here your concepts are clear. We'll start from here. See, we have an up portion here. Yeah, so this is a staircase what we are going to take, okay, in this way. And here you can see we have a lot of places to keep the car. You have a ramp portion here, so this is a ramp from here, and this is a driveway. So everywhere you can see the car place, right? So this is a basement area where you can do the parking of a vehicles. Again, if you come towards this part, you'll have a lift here. Like you can park the vehicle here, and from here itself you can take the lift. And if you want to go to the second or the third floor, you can take a lift from here and you can go, right? Yeah. So again, they have an electrical room here, and then from here they have another staircase which they have given, and from this side they have given one more staircase. And of course, this is a ramp portion what we have, so that your vehicle can come, and from here it can be parked in this particular area. Again, one thing we need to notice here, look at this columns here. All these are the red color column what we have given. Then we have a green color column, and then we have a magenta color column. Again, we know the logic behind this. All the red color column are of one size, then the green color column is of another size, and then this purple color or the magenta color are of another size. Yeah, right. So I hope up to here concepts are clear. And again, it is mentioned here minus 4 feet 6 inch level. That means from the ground level, this particular area, that is the place where you're going to keep the car, it is at the minus level, because of course the basement will be in the lower level. To put it in a better way, you see here, you can see a lot of sand and all. This is actually my ground level. Okay, this is my ground level, and the below you're going to keep the car here. You can see from here, like this is a retaining wall here, but below this you're going to keep the car, right? Okay, that means you still have a space from here to here. So from this ground level, the bottom level where you're going to park the car, that is at minus 4 feet 6 inch level. Got it? And of course, this is your ground floor slab, right? Yeah. So yeah, so that is the meaning of this minus 4 feet 6 inch. Okay. And other than that, rest all things are very simple here. I hope up to here your concepts are clear. Next, once this is done, I'll take you to the one more floor now. So once we are done with the basement floor, right? Again, you can see it here. All the things will be written here. Okay. What is the project name? Who has drawn it? Who has checked it? And if there is a revision number, you can see here revision number 2, because before this already one revision has happened. So this is revision number 2. Again, let us say if the client decides that he doesn't want a staircase here, instead of here, the client wants the staircase from here. So in that case, what will happen? This becomes my revision number 3. So it becomes R3. So usually in the bigger projects, this is I mean, these things usually happen where you're going to get a revised drawing every now and then if the client keeps on changing the ideas. Yeah. So now I'll go to the next one. So the next one is yeah. So it's a ground floor plan. We are done with the basement. Then we are going for the ground floor plan. So this is the ground floor plan. You can see the entire slab in this direction, right? So this is my ground floor slab, ground floor slab. And of course, we are looking at the plan now. So we'll check into the plan now. So again, you can see we have a C now here. So they have given a staircase here. Okay. So this is how exact it looks. Yeah. See, this is a staircase. Yeah, I made one mistake, not a mistake, but for your understanding, here that staircase won't come. In this portion, the staircase won't come because it's a basement. No? We are not given any staircase here. But once we come to the ground floor, from here we are going to, because from here itself you're connecting this with the ground slab. So that is why the staircase is given here. And that is for the very same reason. You can see it here. The staircase has been shown here. And what is the width of your staircase? It's a 10 feet 6 inch. So this particular staircase is my 10 feet 6 inch staircase, and rest things we'll try to see through a drawing. Yeah. Yeah. So now you can see, again, we'll start from here. Again, you're taking a staircase from here. Of course, we have a lift here. Okay. And then you come here, you have a corridor here. And here they are planned to make a restaurant. Okay, this is a restaurant what we have, and this is a kitchen for that restaurant. And then you come from here, since it's a corridor, again this is also a corridor, and this part is also a corridor. Now since it's a kind of a commercial building what we have, I mean it's a commercial come residential building, this ground floor we are using it for commercial. So that is why when you enter from this staircase, again you have a 5 feet 9 inch corridor, and you can see everywhere there is a shop. There's a shop, one shop, and here also you have a shop, right? So in this way everywhere we have a shop. Then after that, again you can see what is written 4 feet 6 inch. That means again for a very obvious reason, from here it is 4 feet 6 inch. That is from this ground level. Yeah, from this ground level, the height of this slab, no, it is at a 4 feet 6 inch, and the bottom place where you're going to keep the car, that is at minus 4 feet 6 inch. Got it? So that is why it is mentioned here. It is plus 4 feet 6 inches. Yeah. And then you have this reception area here. You enter from here, you come here, or you come from here, you have this reception area here. Okay. And after that, again you come here. Again we have a this staircase. I mean, you can see here, initially we had a plan of giving a staircase here, but later we decided not to give a staircase here. Okay, of course it is there in the plan, but later we decided not to give, and that is not there in the entire building now. Okay, yeah, so this is corridor 6 feet wide, and this is also 6 feet wide. And then again you have a corridor, again you have shop here, shop, and then again there's one more shop here, another shop here, and then again this portion is a corridor. Again you have a lift here and a lift here, and this is a ducting portion. Whatever plumbing lines and all you're supposed to take, you'll pass it through this particular duct, and you're going to take it. Got it? So I hope even this is also clear. And other than that, you know about the columns now. Again, the red columns are of one size, the magenta color one is of other size, and the green color are of another size. That means 3 different sizes of column we are using in this particular project. And then of course we have one staircase in this portion also. Got it? Yeah. Now once the ground floor is done, we'll go to the first floor plan. So this is your first floor plan. Again, in the first floor also it is similar to what we had in the ground floor, provided this reception area has been changed into a store area, and here this restaurant and kitchen what we had, that has been turned into another shop and shop. Rest things here, everywhere we had a shop, then we have a shop here. Okay, and then again we have a corridor here. Again we had a shop, again same thing is continued here, and again there is a corridor here. Okay, and then yeah, and other than that, rest all remains the same. There's nothing much changes. Okay, yeah, so here is written confirm cutout in slab required or not, but later we did not give any cutout in this portion because that was not required. Okay, in drawing it was there, but since it's written confirm cutout in slab required or not, maybe the client had some other ideas, but later he decided not to give a cutout here, so we are not given a cutout here. Complete slab we have done the casting. Okay, and then again of course we have a staircase here. Okay, yeah, so rest all remains the same. A very good plan what we have done so far. Next we'll go to the next floor, that is about the second floor. Now my second floor and the third floor, both floor remains the same. I have taken only one drawing. The third floor is a replica of this particular floor. Okay, yeah, again same thing, you have a lift here. This time what we have done, this entire portion is for the residential purpose. Now you see here, once you reach here, again you have a corridor, you have a room here, and you have a bath here. Then again you have a connectivity to this room and a bath here. Similarly, they have given one more room here and a bath, a room and a bath is there. Okay, similarly here what they have given, here they have made another room, a bit spacious. So you have a hall here, and you have a foyer and a hall, then you have a dining, you have a kitchen in this portion, you have a toilet, and then you have a bedroom in this portion. Of course the lift remains here itself, because in a building the lift, the staircase and the duct portion will never change. They are going to be in the same position right from the basement till to the last floor. So that is why this particular area is not changed in any of the plan. Again, if you come here, in the ground floor we had a store in this portion. Now that has been converted into a room and a bathroom. Again you can see a room and a bathroom. Okay, then a room and a bathroom, and that is how the planning is done. Got it? So I think up to here our concepts are clear, and we have understood about the plans. Again what is this all about? You can see this marking. This marking indicates that you're going to do a wall here, and especially it is a brick work. Okay, brick wall. Later the client may use a hollow block, or let us say a concrete block, but here this indicates that you are using a brick work here. But later we'll try to make use of some other block and all, and that is also okay. Okay, all these are the walls what we have. Okay, and this indicates the window. All these are the windows what we are supposed to put here. The blue color, these things indicates the windows. Okay, yeah. So I hope most of the things we have understood through this plan. Again, after this, the third floor and the roof remains the same. There is no changes in that. So that is why I have not shown it here. Okay, so it's written second floor. After that, for the third floor also, we have the same plan here, right? Yeah. So I hope up to here your concepts are clear. We have got an idea regarding how the plan of this particular building looks. And if I put it in this way, now you can see it here. This will be my ground floor, which will be used for the uh, commercial building where you have a shop, and this much is my reception area. And again, this is my first floor, where again I'm going to use for commercial purpose. This portion will be for the store, and this is my lift portion. We have a staircase, and this portion also we have a staircase. Then this portion and this portion, okay, this is my second floor, isn't it? This is my first, this is my second, and this is my third floor. So this portion we are going to use it for the this thing. Yeah, I had the small changes here. Okay, let me tell you. The second floor is as like a plan, like whatever we have in the plan, isn't it? I'll go with this. Yeah, this is our second floor plan. This is how the second floor plan looks. Whereas this is my large floor now. I'll go here. Yeah, so this is my third floor. In the third floor, what they have is, I don't have a plan right now. Maybe I'll add it when I get it. Okay, here it's the same thing. Whatever rooms and all you had here, right? The same will continue here. But this particular portion, you can see this, they are going to make use that as a function hall. I'll write it here as a hall, or maybe for some programs. Okay, or I'll write it as function hall. Okay, function hall. Yeah, so this is this particular area what you can see, right? This much area. Okay, this entire area they're going to use it as a function hall, or let us say a party hall. Okay, so that is not there in the plan, but that is a plan what exactly what we have executed there on the construction side. So hello my dear students, welcome back to the lecture. In this lecture we'll try to see how the footing details are given for this particular building, right? So I'll be taking you to the footing part now. All right, so you can see it here. This is how the footing is given for the entire building. So before we go with that, again there is a lot of revision here. So you can see it here. They have written this is revision number R1. I mean, this is first drawing what they have released. It is written R1. So once this is done, again there was another revision. Again it is R2. Okay, they have written revised position of F12, D13 and G11 columns. They are going to write what all revision has happened there. And again this is R2 revision, and then you come here. So this is my R3. So again, revised position of the column near the well. Okay, so near the well there was some revised here. Yeah, you can see it here. So well is somewhere here. We'll see where the well is. Yeah, yeah, yeah. So the well was somewhere here. So here they have done some revision, I guess. Okay, so this is another revision what they do. Okay, and then finally there's one more revision which has happened. This is R3 only. You can, if you see the difference, see here in this part there is no columns at all, right? There's no columns at all in this part. But whereas if, when you see it here, you can see a lot of columns has been added. So actually why this has been added? Because initially if you look into the plan, we had a lift here, right? So you can see 1 column, 2 column and 3 column, isn't it? So for this they have not given the foundation. Okay, for this they are not given the foundation. So here you can see there is no foundation given. So that is why he has added a foundation here and he has given it here. Okay, so this is center line. Of course, this is a center line drawing what we're able to see. Okay, it's written here grid M, N, O, P and Q are added. That is this one. Where is M, N? Yeah, M, N, O and P, Q. So again, maybe yeah, this is P and this is Q. Okay, this much portion are added. That is 4 numbers of C3 column added. So 1, 2, 3 and this one are added. Dimensions are highlighted. You can see this is highlighted. Rest all are in black color, whereas 1, 2, 3, 4 columns are highlighted, right? So that is how usually the revision keeps on happening. So now your question is that which one we should refer? Of course, the latest revision which has happened is the R3 revision. This is called as superseded drawings. So I'll write it here. These two drawings, no, like R1 and R2, you're not going to use this. So as a site engineer or as a quality control engineer, what we do on the site is that when such revisions will happen, we'll strike out this drawing in this way. Okay, we'll strike out and we'll write it here as superseded. Yeah, so we'll write it here in this way on this drawing. Usually we have to write it in this way only. I'll write it here. So the QC will write it as supersede. So SUPA super. So it is SEDE. Okay, supersede. So let me write it in text. Supersede. Okay, so we'll write it here, and this drawing we are going to maintain it in the different files. See, actually when you work on the site, no, whatever drawings we are getting, we have to put it in the file. I mean, see, when you work as a site engineer, you'll be having a separate file of the drawings. So the QC engineer will be maintaining one more file which is called a superseded file. Okay, superseded files. So in all these files, whatever drawings revision has happened, like say right now we have to refer R3 drawing. So R1 and R2 revision, whatever are the superseded drawing, no, is going to maintain all those in this particular file. So all this documentation we are supposed to follow on the site. So if tomorrow something happens, we have a documentation with us, so we can, fight for that. Like if something goes wrong and something comes, I mean, if people try to blame you, then you have all these files with you so that you can show it as a proof. So that is what usually we do at the site. So again, you can see it here, isn't it? So right now we have to refer this R3 revision, and this is the one we are looking now. Okay, now check here how all those things are given. We'll start from here. Again, we know A, B, C, D, E, F, all these are the grid lines, and again 1, 2, 3, 4 are the grid lines. Basic understanding we have. Again, you can see here he has given the name as C1 F1. So all these red color columns you can see, they have given a name as C1 F1. Then the green color he has given a name as C2 F2. Got it? C2 F2. And then the, yeah, I can call this as magenta color. They've given a name as C3 F3. And then yeah, for this here, this is a staircase portion, right? It's not the staircase portion. This is your a cutout portion. Here he has given the name as C4 F4 footing. All these are your C4 F4 footing. And then after that, yeah, all four are done. So if I go to this particular footing, he has given this as C3 F5. Yeah, for this he has given a name as C3 F5 footing. C3 F3 is done. Yeah, so this is, he has given a name as C3 F5 footing for this entire lift portion. Okay, you are going to put all the three columns, you are going to do the casting at once. It will be a kind of a matte foundation, a kind of a matte foundation here. It is C3 F5, right? So I hope up to here your concepts are clear. So he has given a name as C3 F4, and this is C4 C3 F5. This is C3 F4. Okay, this is C3 F3 as given, C1 F1 and CF2. Okay, C2 F2. Got it. Yeah, so C1 F1 is one kind of footing. Then we have C2 F2, another kind of footing. Then we have C3 F3, and then we have C3 F4, and then we have C3 F5. Okay, so these are total 5 kinds of footing what we have, and accordingly you're going to get all the reinforcement details for this particular building. Again, to check the dimension, like I mentioned, they'll give it for one dimension, I mean for one particular footing. Like if I want for C1 F1, he has given it here for the C1 F1. You can check it out here. See, the distance, I mean the size is 7 feet 6 inch by 6 feet 3 inch. Okay, so this is the excavation level, and then 7 feet by 5 feet 9 inch is the size of your first footing, I mean first step. So the 4 feet by 2 feet 9 inch, this is your second step. This again, here we have used a step footing, and of course this is a column which is 12 inch by 24 inch. Similarly, if you come to the another footing C2 F2, now check for the C2 F2. Yeah, we have given it here. See here, this is C2 F2. Again, it's the same thing, 8 feet 3 inch by 7 feet. Then this is 7 feet 9 inch by 6 feet 6 inch. So 4 feet 6 inch by 3 feet 3 inch. Okay, this is second step, and this is a column which we have 12 inch by 24 inch. Got it? Again, for the C3 F3, try to understand yourself. Okay, try to understand here. And then again for the last one, yeah, C4 F4, I think it's difficult. Yeah, C4 F4, it is given here, it is 11 feet 3 inch by 19 feet 3 inch. The other thing, you cannot see it here. For that you are going to refer the cross section part, and we'll see the cross section part in the next lecture. How the cross section for this entire building is given. Right now we understood how the location of the footing is done, and everywhere it is isolated footing. Only in this portion they have put a combined footing, or I can call it as a mat. And also here also they have, in this lift portion also we have a kind of a mat footing. Okay, yeah, so I hope up to here your concepts are clear. We were able to understand something new called as superseded drawings, and we have understood all those things. How the elevation for this particular building is going to look, right? So we have understood the plan also. and we'll try to see the elevation part, like how my building is going to look, right? Yeah, so you can see it here. This is I mean, elevation in the sense, the section part they are showing it here. Like if you're seeing it from the east side, or if you're seeing it from the north side, how your building is going to look, that you can get. And also what is the floor to floor height, and all those things you're going to get it here. So we'll start from here. So to put it in a better way, you see here, this is a PCC what I have, isn't it? And after the PCC, I put the footing, and then of course this will be a plinth beam over there. Okay, and then this is how the basement floor is all about. So this is a basement floor what we have, and from here to here, this is a road level, which is at the 4 feet 6 inch. Like if you understand, from here, this road level itself was this particular level. So this is my road level, right? Yeah, yeah. So this is a road level. From here to here, you have to do, from here to here, the height is 4 feet 6 inch. And again, from here to here, next we have a ground floor. Got it? Yeah. And from ground floor to the first floor, it is a 10 feet 6 inch height. And first floor to second floor to floor height is again 10 feet 6 inch. Second floor to third floor, again, it is 10 feet 6 inch. And third floor to terrace floor, it is again 13 feet 3 inches. Okay. Again, why this terrace floor, this side it is 13 feet 3 inches. The reason being is that I told you the last floor what we have, that is this particular floor, you know, this particular floor what we have, this much area, we are going to make use it for the party hall and all. So that is why we have increased the height here. Okay, so that is again the same, you can see it here, it has been reflected in the drawing. Where rest all the typical floor like second, first and ground, it is 10 feet 6, 10 feet 6 and 10 feet 6, whereas this is 13 feet 3 inches. Okay, yeah. So other than that, you can see what all things it's mentioned here. CC is a cement concrete bed, that is a PCC bed. Then you have a RCC footing. This is your RCC beam. Then this is your RCC slab. Again, it is a beam and a slab. And this is the middle portion. All these are the block work masonry. Like I told, it's a brick work. So here they have mentioned it as block work. So throughout the building, we'll make use of a block work masonry. Okay. So this is my block work masonry. And this is a window, of course. And this is a parapet wall. So the parapet wall, in the sense, when you go for the terrace floor, we are going to put a small wall, which is a parapet wall, which usually will be of a 3 feet height here. So the height is mentioned here, it's a 3 feet. Yeah. So other than that, the rest all things remains, I mean, it's understood for us. Similarly, I'll take you to one more section now. Again, this is one more section. Okay, again, this is a door. The height of your door will be 7 feet. And again, this is a RCC beam here, second floor, third floor, and the terrace floor. Similarly, we'll see it here. Again, this is a east-west section. Okay, again, the same thing, basement floor, road level, ground, first, second, third, and terrace. But here you can see the staircase part. So this is how your staircase will be running in your building. And this is the railings what we have here. Okay, and again, you have a retaining wall in this portion. Now it is mentioned retaining wall here, isn't it? So again, you can see a wall here. This is actually wall. It's not a beam here. Okay, it's a wall. So throughout the building, we have put a retaining wall, because what will happen, since we have from here, we have gone 4 feet 6 inches down. Later, what will happen, the soil will try to come inside. In order to stop that, we have put a retaining wall all around from here to here, all this portion, we have put a retaining wall. So that is why the same can be seen in the drawing. Now mentioned that you have to make use of a retaining wall. Okay, so this is a retaining wall what we have. And rest things are simple. Okay, and then we'll go to the other drawing. Again, here also it's the same thing. Section at NN, the height is 7 feet. Yeah, RCC retaining wall is done. Yeah, oh, this is already, we have seen this. Yeah, so that's all. So this was all about your section part, how your building is going to look, and what is the typical floor to floor height and all. So you can see the typical floor to floor height, that is the top of this slab to the top of this slab. It should be 10 feet 6 inch, which is a floor to floor height. Okay, yeah. So rest all things are simple, and we have understood it. And all these are your sunk slab. Okay, so these are your sunk slab, in the sense wherever you have a toilet portion, there you are going to give a sunk slab. So all these slabs are of same level, whereas we know the sunk slab will be sunk by, let us say, 200 or 300 mm, and that is a sunk slab what you can see. So this is also sunk slab, and that is how the sunk slab looks. Yeah. Foundation details for this particular building. So if you remember, in the previous lecture, we had understood about all these footings, right? Like C1, F1 footing, then we had C2, F2, the lift part and all. Now for the same building, we'll see how it has been worked out. Okay, so again, you can see it here, proposed construction, and it's given here column footing details. So we'll start with one by one. Again, this is for C1 F1 and this is for C2 F2. And then after that, they have given this for C3 F4 and this is for C3 F3. Okay. So 3 and another one, 4 things we have got. So again, this thing we already understood. Okay. Again, you can see it here, C1 F1, there are 29 numbers of C1 F1 footing. Now I'll just zoom out this so that you get an idea what exactly I'm trying to tell. We already understood this through with our first commercial building. Again, 6 feet 3 inch by 7 feet 6 inches excavation line. And again, it's a step footing. This is your first step, which is 5 feet 9 inch by 7 feet. The second step is 2 feet 9 inch by 4 feet, right? And then again, the column size is 12 inch by 24 inch. So it comes out to be 2 feet. Now again, it's mentioned here, steel you have to provide 12 diameter bar at 6 inches center to center spacing in both the way, along the shorter span and also along the longer span. And RCC footing first step is 7 feet by 5 feet 9 inch by 12 inch. Okay, that is a depth. And second is 4 feet by 2 feet 9 inch by 12 inch. This is my second step. Coming to the column, it's a 12 inch by 24 inch. So in the column, you're supposed to provide a 20 diameter 6 bar and a 16 diameter 4 bar. So this 1, 2, 3, 4, the middle 4 bars are of 16 diameter and the outer 3 and this outer 3, all to 6 are 20 diameter bars. Again, coming to the lateral ties, you have to provide a 8 mm lateral ties at 6 inches center to center spacing, and one is your mastering and the other one is going to connect the center portion, right? Yeah. And coming to the cross section, again, it's understood you have to provide a 4-inch thick PCC bed. Then this is your first step, which is a 12-inch thickness. Then this is your second step, which is a 12-inch thickness. And then of course the column and the reinforcement, you can see it here. So this was all about the C1 F1. Similarly, I'll zoom out this, just concentrate here. This is for C2 F2. Right, it's hope it is understood to you. Just concentrate and try to understand. And coming to the lateral ties, here we have 3 lateral ties. Like one is the master ring, which will connect all the rebar. Then we have another 2. One, yeah. Yeah, then we have another 2. I think it will be connected in this way. That is, if I try to draw it. So this will be your mastering, okay, which will be connected everywhere. And after that, the next one will be something like this. Yeah, so from here to here, it will be connected. Okay, and the next one is going to be connected in this way. Yeah, this one. Okay, so this is how the connection will be done. I think, yeah, so that is how the connection should be done. Let me check it once again. So one will go completely, the other one will be completely in this way. Yeah, so we'll do in this way. So this is your mastering. So after that, maybe from here to here. Okay, and then the next one will be from here to here. Yeah, from here to here. This is how it is given. Okay, yeah, yeah. So I think that is not the way. I rechecked it. See, actually it will be something like this. So one will be completely okay. That is your mastering. After that, your next ring will go in this way. This one. Okay, and then the next ring will be this one. These 4 bars. Okay, so this is how the ring is given. Got it? So this is how you're supposed to do it. The previous thing what I told, that is not the right one. Again, the one which I explained now, no, that is the one. One is a mastering. The next ring will be connected in this way, and then the next ring will be connected here. So 3 rings. So that is why you can see 1, then your 2. This is your 2, and this is your 3rd. Yeah, now it is visible to you. Let me quickly do that. This is 1. Okay, then we have this second one, and then the 3rd one in this. Got it? Yeah. Yeah. So again, for the cross section, again you have to refer here. This is a cross section. Now we'll come to the C3 F3 footing, which is 9 numbers. And again, here it's all same thing. There's no changes. Again, one is a mastering, and the second ring we have. The rest all things you can see it here. So you know it how to understand by this time. And now coming to the C3 F4 footing, that is a lift portion. Wherever we had those lift, isn't it? So that is a point where these things are going to come. Again, coming to the cross section, you will be able to understand, of course, the PCC, and then a kind of a raft foundation is given here, okay, which is 1 feet 4 inches. So it is supported by altogether the 4 columns will come. 1, 2, 3, 4 columns will come. Since we are seeing the section now, so that is why we can see only the 2 columns here. So this will go up to the basement floor. Okay, and we have a retaining wall here. So this is a retaining wall. So I'll show you the exact picture of that. See, yeah. So that retaining wall is this particular retaining wall. Okay, you can see everywhere here. So all these are my retaining wall. Yeah. So this RCC retaining wall, it is given. You have to provide a 8 mm bar at 6 inches center to center spacing, and also 8 mm, that is a main bar, and the other one, that is this dot, and the distribution bar and the main steel, that is longitudinal steel and the horizontal steel, both are 8 mm bar at 6 inches center to center spacing. And since here we are going to give the reinforcement, it is mentioned you have to provide a 10 diameter bar at 6 inches center to center spacing. Okay, and here the reinforcement will be bottom and also the top mesh. You can see it here. Bottom must you have to provide the bar. So in this way, this is my bottom. Okay, and also the top side. Okay, so usually in the mat foundation and all, we give top and bottom both the meshes. Okay, so that is what it is mentioned here. 10 diameter, 6 inches center to center, it's a both way. Bottom also same thing, top also same way. Shorter and longer span both, it's the same thing. Okay, yeah. So this is that plan view of that. Okay, first lift and second lift, 2 lift portion. Your column here, column here, column here, and column here. And this is your RCC retaining wall up to 9" above the basement floor. And this is RCC footing first step. You have RCC column here. And again, steel it is given 10 diameter at 6 inches center to center spacing. Got it? So that is how it is. So this is a section for that particular building. So up to here we have understood about the foundation details and all. Okay, so what you are supposed to do is try to understand what is the size of a footing given, and based on that try to have a rough idea. If you're putting up a basement plus ground plus 3-story building or a 4-story building, what is the footing size that you're getting? So now through our knowledge we can come to idea that we have to provide a footing of 7 feet by 5 feet 9 inch. But see, again, this is just a thumb rule to get an idea. So now you know the fundamentals. Again, I'm not going to explain that from the very scratch. So you know how to connect the column to column and why the plinth beam is given. So quickly have a look at it. So try to understand whenever you provide a plinth beam, it will be connected from column to column. And you also know the naming, how it has to be given. The same can be reflected here also. Like they have started from here left to right, RB1, I mean PB1, PB2, PB3 and all. So once they finish up to here, that is once they finish up to PB21. So this is PB21, the last one. Okay, PB21. Then again we don't have, started from the left again. So again you can say PB22, PB23, PB24 and so on. So that is how a naming will be given for the plinth beam. Other than that, what we are supposed to see is that, see, we have a lift here, lift pit and lift pit. Lift pit in the sense that is a place where the lift car is going to go down. That means, see, your lift is going to stop up to the basement only. Got it? So even below that, you are going to do around 2 to 3 feet of extra space, so that your lift will be something like this, isn't it? If I draw the lift portion, okay, this much portion will go down. Okay, let us say this is my basement floor. Let us say this is my basement floor, and let us say you parked your car here, and from here itself you are going to take the, what is that, lift car. Okay, so if you are going to take a lift car from here, again this much portion will be there, it will be going down. Okay, of course you are going to provide a spring here. So nowadays those mechanism has come where in the lift you are going to give the spring, and this is going to go down. Okay, this much portion. Okay, so hence we call this as a lift pit here. But here one right now we are in the basement floor only. Okay, this is your basement floor only, and there this how your lift is going to come. I mean, if you want to get into the lift, you'll be standing here. Okay, this much portion will be there inside. I mean, this is how the lift is made. Okay, and this much portion will be going down inside the ground, and you'll be having a spring arrangement to that. Okay, so that is how it those things will be done. So put it in a better way. Let me show you one image for that. If I have, yeah, exactly. Yeah, so you can see it here. This is one lift pit, this is a second lift pit. Okay, so the one which I was speaking, no, your lift pit will go up to here, and this is your plinth beam. I'll show you the plinth beam layout now. So this is your floor here, okay, and from here you're going to make an entry into this lift, okay. Once, see, now it may not be clear for you, but once the entire building and all will be done, once you put the tiles, not the tiles because it's a parking space, you won't be putting tiles, a good I mean PCC you're going to put it here, okay, or maybe you're going to put a grade slab here, okay, and then that is how it has to be done. Got it? Yeah. Yeah, again the double bars, we know this was my staircase portion, we have to leave the double bar, and you can see the same has been done here. I mean, of course they left the double bar here, and then the staircase was done, okay. So this is that, but right now whatever plinth beam you are seeing it here, isn't it? So I'll show you the same thing on the drawing. So this particular is PB13, which is a 9" by 15", and same has been executed on the side. Other than that, rest all things we know how to read the drawing. PB1 9" by 15", it's the size of your beam and all, and grid lines remains the same. Other than that, there is nothing much. Yeah, now you can see the retaining wall here. This from here, RW stand for retaining wall. So all these are your retaining wall, okay. From here in this way up to here, you have to provide a retaining wall which is green in color, okay. So practically how the retaining wall looks on the side, we'll see that. So you can see a wall here. This is my retaining wall. This entire thing is my retaining wall, okay. Yeah, so right now this retaining wall, what you can see here, right? So I'll show you where exactly in the drawing this particular wall replicates. So if I go back to the drawing, right now we are looking at this position. We are here. This two wall you can see RW and RW. So this particular wall what we are looking at, this is that portion. Okay. Similarly, we'll see the other part also. Yeah. Again, of course, this is that entire retaining wall. Okay. This retaining wall you can see. So in this way it has gone, isn't it? Same thing if I want to show it in the drawing. Again, this is that portion, the front side. Okay. So let me do it in this way. Yeah. Now is it visible? See. Yeah. So this portion it is, okay. So this much retaining wall you can see, in this way it has gone. Same thing you can see here, it has gone. And this portion is this particular portion, it has gone straight. And of course it has gone straight in this way. I mean in this way. Okay, it has gone in this way. Then again this one. Again like this, it has gone inside. Again it has gone inside in this way. Then out in this way. And this is how the entire retaining wall is going to look. Got it? Yeah. So I hope up to here your concepts are clear. You understood what practically drawing we are seeing and what practically on the side it has been executed. The rest all things remains the same. Of course, the lift PT is here, and this is how they are given a beam here in the incline, not the incline. I mean, it has gone in. It has been connected from this column to this column because the site itself was something like that. And rest all things remains the same. Nothing much to explain here. Yeah. So other than that, I will quickly see the schedule of RCC plinth beam. Again, I will not explain all those things, how this steel has to be understood. But just to understand the drawing, we'll quickly see that. Again, all the grouping has been done. But the breadth and the depth of the beam is given. Again, the bottom steel, which is a straight, then the curtailment, again, it's 0.7 into L1. Top steel will be a mid span. Top steel at continuous support, top steel at end support. Again, straight up, what they have done is everywhere like I mean at the support they are given a lesser spacing of 8 mm at 6 inches center to center spacing. Rest in the sense the middle portion they will increase it to 8 inches center to center spacing, and we know the reason for that. And wherever there is a cantilever beam and all, they are going to put a remark like PB12 and PB50 is a cantilever. You can see it here in the remark they are going to put, so that the person who does the execution on the site will not make a mistake there. Yeah. Now in the cross section of this, you can see the retaining wall here. See, this is your basement floor level, okay, and this is how your retaining wall is going to start. So this is a retaining wall which will go up to 3 feet 1.5 inch. Again, for the retaining wall, how the steel has to be given, it has to be 8 mm at 150 center to center spacing, and here it is a 12 diameter 3 bar, and here also it's a 12 diameter 3 bar you're supposed to provide it here. And then of course all this 150 150 150 150 are supposed to do it, okay. And same retaining wall we have seen it. This is how that entire retaining wall is going to look. Okay, so this is how that retaining wall is going to look. So I'll show you one practical drawing also for the retaining wall so that you get an idea. So this is how that retaining wall is going to look. Okay, you can see you're going to put a starter there once, okay, and then you're going to put a wall something like this. So all this spacing, you're making use of a 8 diameter at 150, 150, 150 horizontal. And I mean this horizontal, and even this vertical bar also, it's a 150 center to center spacing. Okay. And even in the drawing, you can see same thing. It's a wall. You're seeing it from the top, isn't it? That is why it's looking something like this. You have to provide a 12 diameter 3 bar here, 12 diameter 3 bar, and all these things are 8 bar at 150 center to center spacing. And same, you can see it practically here. So it's the same thing. Okay. They have done. Yeah. Yeah. Got it. Yeah. So up to here, it's a ground level, that is 0, 0 level. And from there, of course, you're going to do that wall masonry, and that is how the basement slab will come over there. That means if you want to understand this particular portion, so what exactly it indicates. Yeah. So this is that portion. Okay. So if I do it in this way, yeah, see it here. So this is a ground level. Right now, this is my ground level. Okay. And from the ground level, you can see some portion of my retaining wall has come. You can see from the ground level, some portion of my retaining wall has come. And from there up to the this portion, that is your beam. Okay. You're going to do the, what is this symbol indicating? That is block work. Right now we have not done. Later we are going to do whatever gap you can see, it will be done with the block. You're going to do the block work. And this is your basement slab. This thing you can see, isn't it? This top level is a basement slab, and you can see already a basement slab has been put up here, right? So whatever is there in the drawing, the same has been executed on the side, and that is how it is. And this height from the ground level to the top of the slab, it is 4 feet 10 inch. So that means practically this particular height, what you can see from here to this side, it is a 4 feet 10 inches what we have. Got it? So that is how you have to understand the drawing, and that is how it is all about. Yeah. Okay. Yeah. So other than that, these are the sections what they have given here to put to get an idea about the beam. You have to provide 4 diameter at the top. 4 bars at the top, 4 bars in the bottom. Again, it's a 12-inch depth what you have from the ground level. This is your plinth level. The top plinth beam top is called as plinth level. And this plinth level, what you can see, I'll show you on the drawing. Practically I'll show you. Again, you can see this is a plinth level. So I'll show you the same thing, plinth level. Yeah, so this can be a better picture for that. Yeah, so see it here, same thing. Okay, this plinth level, this is a plinth beam what we have put, so it's a plinth level here. So all these are my plinth level. Again, for this particular beam, they're given it like what you are supposed to provide, how many steel at the top, how many steel at the bottom you are supposed to do. All those things will be written here. Okay. Yeah, slab layout for the basement flow, and we'll try to understand that. So right now I'm into the basement roof slab layout. That means when I say basement slab roof layout, this is my basement, right? And this particular slab, no, this is a basement roof slab for me. Okay, so we'll try to see that how the entire layout is worked out. So this is that entire layout what we have. Okay, and again, for the very same reason, we have a staircase from here. We know the lift portion was here, and this were the 3 columns we had done. And of course, then you will make an entry from here. Okay, and all this other beam and the slab layout what they are given. We'll start from here. Again, the naming is now, right now, this is my beam. So right now we are looking into the roof level beam, right? So again, we'll not write PB1. Plinth is already done. Now we are going for the roof portion. So again, we'll start with B1, B2, B3, and B4. So in this way, wherever the beam is required, we have given the beam everywhere. And you can see the sizes of the beam like 12-inch by 18-inch, 12-inch by 18-inch, and so on. All these are the beam number and the beam sizes. And coming to the slab, again, it's given here 5-inch thick slab. All these are your slab. And this direction indicates that it's a 2-way slab. And here it's a 1-way slab. You can see here, it is 1-way slab. The load will go on this beam and on this beam. So this is a 1-way slab, which is 4.5-inch thick. And this is a 5-inch thick. So in this way, all the details has been given here. And that is how you are supposed to understand. Again, we have a staircase in this portion. Here we have a staircase. Again, when you're doing the casting of the beam, you're supposed to leave the double bar inside this beam. In the same way, here also you have to leave the you have to leave the double bars when you're going to do the casting of this particular slab. Okay, and once that is done, this double bar will be later utilized to put the staircase. That means, yeah, if you can see it, yeah, like you can see when I casted this slab, that is a basement roof slab, I'm going to deliver double bars inside this, and later this double bar I'm going to use and make a staircase out of it. Got it? So during the casting of that, we are supposed to do that. So the same thing was mentioned here, that you have to leave the double bars for the staircase at 12 diameter bar at 6 inches center to center spacing, and rest all remains the same. So that is how we are supposed to understand this drawing. Okay. Again, you have a duct here, that is no slab here. Here also you don't have slab. Here also you don't have slab because it's a lift portion. So again, you don't have slab in this portion. And wherever there is a slab, they are given it here, the thickness of the slab and the naming for that. So this was all about the slab layout for the basement. And other than that, coming to the beam details now, right? Because so far we understood about the beam naming and all, but we don't know the reinforcement here in B1, B2, B3. For that, we are supposed to look into the schedule of RC beam, like we saw it for the plinth beam. And here all the sizes has been given, whatever is a beam size. And again, the same thing, bottom steel, straight curtailment, top steel is your mid span, extra steel at continuous support and extra steel at end support. And again, the stirrup, everywhere it has been same, 6 inches, somewhere wherever there's a requirement of 4 inches, they're given a 4 inches. And then again, everywhere it is 8 inches. Got it? So this is how the entire drawing is worked out. And wherever there is a cantilever, they are mentioned like cantilever and cantilever, so that it is easy for you to identify on the side. So this is how the entire beam layout is worked out. So just have a look at it, because I'm not going to explain, since we are looking into advanced course. And by this time you should develop this knowledge by looking at the drawing. You should be in a position to understand. Okay, so that is why, again, it's very simple. I've explained you. Only the thing is, here you can see in here the number of bars will be more, since it's a roof beam. So more load will be coming from the slab, and also the diameter you can see like 16 diameter and all, we are used it here. Okay, so that is how you are supposed to understand all these structural drawings. Yeah, so I hope up to here concepts are clear. Again, when they give like 16 diameter 2 bar and 12 diameter 1 bar, how you are supposed to put this 16 diameter 2 bar will be outer, and your 12 diameter 1 bar will be in the middle portion. Got it? And the same way here also it's the same thing, 16 diameter 3 bar plus 20 diameter 2 bar. So in this case, you can provide this 20 diameter 2 bar in the second layer. First layer, you can provide a 16 diameter 3 bar, and in the second, no, yeah, in the second layer, you have to provide a 20 diameter 2 bar. This is how you are supposed to give it in the mid span in the top steel. Okay, yeah. Yeah, so rest all things are simple. We can, and just in case you have doubt, you can always ask in the comment box, like how the steels are provided. Hoping that you know all these things, how it is being provided, because if you have taken my basic course, you are in a position to understand in the advanced course. Okay, but still, if there is any doubt left, you can ask it all anytime. So we'll see you back in the next lecture. Thank you.